Yeah. Morning, everybody. Online, can you hear me? Can you see the screen?
Yes, sir.
All right. Hello, ready now, you know. All right, so my first concern before we even start is that I see some people online who should be in the class. I don't like that. There's some persons send me the excuse, feeling sick and so on, but some persons I don't hear nothing from them, they just don't turn up to class today. All right. If you're going to continue to not come to the live class or the face-to-face class when you are supposed to, I'm not going to bother with this online thing. Understand? A person is using it as an excuse to not come to class. I don't like. Mute the mic, please. Mute the mic, please. I don't like when persons don't come to the face-to-face class. I don't like the online thing, and I hate it. Because when you're online, you don't pay attention. Parents tell me, you don't pay attention, you're playing games, you're looking at videos, you're not focused. So when you're supposed to come to the face-to-face class, you come to the face-to-face class. So Sunday students, you come to the face-to-face class on Sunday, and you can join online on a Monday. We're just doing that for extra work. And the Monday students, you come to the face-to-face class on a Monday, and the Sunday students join online. We're just doing it in a way that everybody can benefit, right? But you need to come to the class. All right? All right, let's go. So this paper is what we did yesterday. One of the papers we did yesterday. We'll be working on the other one tomorrow. This is actually the January 2021 paper. So it's a very recent exam paper. So the structure of this exam paper is of the format of the standard that your exam paper is going to be this year. Same syllabus, same structure, and everything. Get me? Mr. Birham, you did the papers yesterday? No, ask if you print it. Ask if you did it. If you did it. You did it? All right, good. All right, so let's get into it. So remember, tomorrow I'll be doing the other paper. All right? Tomorrow I'll be doing the other paper. So aim is for you to market yourself. See the mistakes that you made. Learn from your mistakes. Any question you got wrong, you need to go and do it. Redo it. 5 times if you have to. Any question you did not do, but you couldn't do it or whatever, you know, go and do it. The video is there to assist you. If watching the video you still can't understand something, then you let me know. Send me a message and say, sir, I'm doing over this question. I watched the video, still don't understand something. And let me see if I can explain it to you some other way than I'm doing it here in the class now. The method I'm using in the class now, or the approach I'm using in the class now, is as if you already know the topic and I'm not teaching it from scratch anymore. So I'm doing the question as if you're in the exam now, this is what you need to do. It's not me teaching it from scratch and explaining everything down to the wire now. What I'm doing now is doing it as I would want you to do it in the exam room so that you can finish the exam in time. And you give the examiner enough information for them to give you your marks and you get the full marks. That's the approach I'm using. Remember, I would have gone through all the basics, all the topics, teach them from scratch, build them up from the basics, come right up, explain everything. All of that is there. You have done that already. Now it's application time. You're applying your knowledge now to solving the questions. Right? So if I'm doing the bearings question, I'm going to go back to the theory again and say bearings have to turn to the right and all that thing. No, we're just going to do it. If I'm doing sine rule and cosine rule, I'm not going to go back through and show you sine rule formula, cosine rule formula, and say this until that you must use it. I might say it along the way, but I'm not going to delve deep into these things anymore. So what I do now is basically what I wanted to do in the exam room, or something like that. If you don't know what to do in the exam room, I'm giving you an example of what to do in the exam room to get your marks. All right, let's go. First question. Always is a calculator question. That's why I'm leaving the calculator on the screen. And another thing, you must make sure your calculator is in degrees. One of the students yesterday kept getting the wrong answer for something. And it was because his calculator was in radians. You have to make sure that little D thing is on your calculator, or the letters D, E, G. That's why you know your calculator is in degrees. You don't want to see R, you don't want to see R-A-D, you don't want to see these. You don't want to see G, and you don't want to see G-R-A-D. These are some other things the calculator can be. You don't want to see these. This is what you want to see on your calculator. If you don't know if you get it there, you check me. Let me put it in that mode for you, and you don't take it off again. I must always check. I must find out how you get it into that mode as well. All right? You have to put the calculator in degrees, because you're working in degrees. When I was in school doing CSEC math, we also had to do questions in radians. The CSEC reduced the syllabus a lot, and they took radians off your syllabus. So you don't have that to worry about again. You only have to worry about working in degrees now. All right? So that made it easier for you guys. All right, so let's go. So the first question always is to use a calculator, see there, or otherwise, and they want the exact value of these things. In other words, you're not going to give it as a decimal and round it off or anything like that. Give it as an exact value. So all you need to do, because I say use a calculator, then it's 2 free marks. Put this in the calculator as exactly as it appears there. And just write what you get. Just make sure you put it in exactly as it appears there. And I keep saying it. That is why you need one of those textbook display calculators that you can enter this in the calculator and see it as it appears there. Don't like to see those other calculators because you don't know how to put this in the other calculators the right way and get the right answer. So it's best to get one of the calculators that you can type what you want in there exactly as it appears on the paper. All right, so it's a matter of putting this in the calculator. So it starts out with a mixed number. And it is 1 and 4 over 7. So all you need to do here now is enter it the right way, exactly as it appears there. Plus, that's the only thing you need to be careful now. Fraction of 2/3. Then you're subtracting another mixed number of 1 and 5 over 6. And it gives me that as a decimal, but the calculator that you have will also be able to give you as a fraction, which is the exact value right there. 17 over 42. So everybody's supposed to get that. You don't want to lose marks on these easy questions. Every mark important. 17 over 42. Done. That's it. Next question. Same thing. Write this as a fraction in lowest terms. Now, this can be worked out enough. You can also put it in the calculator. Let's put it in the calculator and see what we get. So I get the cube root of 27, which you should know is 3. Oh, that is on a fraction. No, so I don't want it like that. I want a fraction on numerator. I want the cube root of 27, which you know is 3. And you're dividing that by 9 squared. 9 squared. And as a fraction, this is it. 1 over 27. So the answer is 1 over 27. But this one I might want to show a little bit of work because they never say use a calculator. Let me see the first part. This part specifically say use a calculator. This part didn't say that, so I might want to show some work for this one. All right? Let me show some work. But I know the answer is 1 over 27, you know. Calculator told me that. But let me just show some work. So the cube root of 27 over 9 squared. I'm not even going to write this as 81 because I'm trying to simplify. I'm going to write this. The cube root of 27 is 3. That's 3 times 3 times 3 is 27. 3. Put that over 9 times 9. This 9 squared is 9 times 9. I'm not going to write it as 81 because I'm trying to simplify it. I'm not going to expand it or build it back up. And then I just need to cancel 3 out of this 1 time, 3 out of this 3 times. And so the result becomes the same 1 over 27 because this is the 1 over 3 times 9 is 27. So let's show some work because this one did not say use a calculator. So let's show some work, but that is the answer. All right, nice and easy. Next question down here. It says the thickness of 1 sheet of cardboard is this. Very thin. Millimeters. Note it is in millimeters. Everything important. It says a construction worker uses 75 sheets of a cardboard stacked together to insulate a wall. Insulate a wall is to make it be that temperature, heat can't pass through it. So if inside is warm, it stays warm. If outside is cold, it stays cold. Heat can't pass through. That's what insulation does, right? Prevent the transfer of heat. Anyway, don't really matter. It says, show that the thickness, the exact thickness of the insulation is this. So basically, it's 75 of these you have. So it's a matter of multiplying them. So the thickness is going to be 75 times this, which is 485 times 10 to the minus 2. I can put that in the calculator again if you want. 75 times 485 times 10 raised to the power of negative 2. Let's get the same thing. 363.75. 363.75 millimeters. So that was shown. Easy like that. All right. Next part says no. Write the thickness of the insulation. In other words, this thing. Write it as 2 significant figures. All right. So I'm going to write it back first. 363.75 millimeters. That's what the exact value of it is. The exact dimensions. But I want it to 2 significant figures. But the first significant figure is the first non-zero value from left. So that's the first significant figure. That's the second one. You're correcting it to these 2 significant figures. Now remember, the size of the number cannot change. This number is in the 300s. So the answer must also be in the hundreds, in the 300s. The values in the hundreds, the answer must be in the hundreds. The values in the tens, the answer must be in the tens. If the answer is in the values in the ones, the answer must be in the ones. So using this 3 to correct that as always. So it's not going to increase that 6. So you're going to put 36, but then this 3 becomes a 0 because the size of the number must stay the same. So the 2 significant figures, that's what it is. 360 millimeters. The 2 significant figures. See? 2 significant figures. And the number does not change. The size of the value does not change. Still in the hundreds, 300 and something. You can be estimating 363 to 2 digits and then it becomes 36. That don't make no sense. That will make sense. Just an approximation you're using, the 360. So instead of telling somebody, suppose the person going to buy some insulation at the store and they want 363.75, but only sell them in tens. You're going to buy 360. Because they only sell it in tens. You're not going to buy 36. right? 36 is far, far, far from 363. All right, so that is that. Next thing I want is corrected one decimal place. Again, the size don't change. So I'm going to write this again. 363.75 millimeters. And I want it to one decimal place. So we're correcting it to one decimal place. This is that one decimal place that we need to correct it to. This 5 is what we use to correct this 7 here. The 5 will increase to 7. Any value of 5 or more that comes after that decimal place will increase it. Will increase it by 1. So it's like increasing the whole of this by this 0.1. So it becomes 0.8. If you add the 0.1 to that, it becomes 0.8. So this becomes 363.8 millimeters. This is the answer. The next part now says they want it in standard form. So this one they gave us, this was not standard form, enough. This was not standard form. Let me point that out here. That was not standard form. Standard form, the decimal point would have to be right here after the first digit. So standard form, it must have the decimal point after the first non-zero digit. That's what standard form is written. All right, so let's go back to it again and write it in standard form. So the same number, 363.75 millimeters. They want it in standard form. So essentially, we want to adjust it such that the decimal point comes to here. One decimal point to go to there. Remember, you can think of it this way too. This is a big number, you know. So that you're going to raise a 10 to some positive power as a big number. But a small number like decimals and so on, you raise it, it's going to come to a standard form times 10 to some negative power. So that's a little hint that because the number is in the hundreds, you're going to get 10 squared. All right? So anyway, so how would you do it mathematically? How can we do it mathematically? We need decimal point to move 2 places to the left to there. To move the decimal point 2 places to the left, we can divide by 10 squared. We're working in 10 to some powers, you know. So it's like we're doing this to the number. It's like we take the number, I don't want that speed. Let me write it a little bit higher. All right, so like we take the number, the 363.75, and it's like we divide it by 10 squared in order to move the decimal point here. But because we divide it by 10 squared, we have to balance out that division by 10 squared by multiplying it back by 10 squared. And this calculation in here is what will move the decimal point for us. You don't have to do it this way, you know. I think maybe this is a lengthy way to do it. Right? Just believe me. But I just want to give you a process. Right? I just want to give you a process to use to do it. And so it becomes, this one move the decimal point. The decimal point is now here. So we can write now 3.6375. And you write back this now, 10 squared. That did not operate. This 10 squared under here operated by moving the decimal point to give us this. And then you multiply by this 10 squared. That is it in standard form. Easy as that. All right? I think it is difficult sometimes to explain simple things. Funny, but simple things are sometimes more difficult to explain than complicated things. Because it's like for simple thing, you don't know what to say to explain it because it's so simple. But so you go. Let's continue. This question is an exchange rate question. Remember, I told you guys, do exchange rate questions as ratio questions. If in doubt, do them as ratio questions. Because when you're doing it as a ratio question, all you're doing is multiplying and dividing by values to get what you want, to find the information that you want. So do your exchange rate questions as ratio questions. It is not complicated. All right, let's look at this one now. It says Marco is on vacation in the Caribbean. He changes 4,500 pesos, that's Mexican pesos, to Eastern Caribbean dollars. So it's going from Mexican dollars to EC dollars. And for this 4,500, he received this amount of EC dollars. 630. So it simply means that this equal that in terms of the exchange rate. They want us to complete the statement below for the exchange rate. In other words, they want us to take this comparison, bring it down to this, to see what one EC dollar is. Really like a ratio. So start simply by saying 630 EC dollars is actually 4,500 Mexican dollars. Start out in the same order that this is. And all that it is that we want this side to become 1. So if you have 630 and want it to become 1, you're going to divide it by 630. So I'm going to divide the side by 630. And some also divide the side by 630. And it tells me what the answer is. So when this side now becomes 1, I'm working this value and I'm putting it here. So it's 4500 divided by 630. As easy as that. 4500 over 630. And it gives me that. I'm going to put it to 2 decimal places because it's money. So I'm going to write. I don't know why they didn't use values that are exact, but that's how it is. You're going to write 7.14. Correct it to 2 decimal places because it's money. That is it. It's money, you know. So you put 7.14. That is it. I'd prefer if they use values that are exact and give you exactly 2 decimal places, but not all the time we do exchange rate and get exact money anyway. So they are mirroring what happens in real life. So this is what you would have to put. Because it's money. You never say exchange rate go to 3 or 4 decimal places, always 2 decimal places. So some of the money not going exact. And you run it after the nearest cent. All right, that is it. Everybody good so far? So we're aiming for 35. Everybody must have 9 already. Next week is 40, you know, so we have to improve this week. Next week is 40. You have to improve. The way to improve is to redo the questions you get wrong. Make sure at the end of this session, or by the end of this week, you understand everything where you get wrong this week, you understand them before next week comes. That's the aim this week. To understand everything where you get wrong this week, make sure you understand it going into next week. You can't go into next week with the lack of that knowledge. Don't make no sense. But you're going to get similar questions. And that is why we can move the pass mark. Because I expect you to improve your knowledge, reduce the number of mistakes that you're making. That's what we expect to happen between this week and next week. So you must can improve by 5% next week. You must can improve by 5%. And then it's going to be some big jumps after that. So after that, we're going to increase it by 10%. But you have to put in the work to eliminate the mistakes, overcome your misunderstanding, right? And learn to do the questions that you don't know how to do properly by doing them repeatedly this week. Binge on the paper, do it over and over again. Remember, I get 2 mock exams this week again, you know? 1 Wednesday and 1 Thursday. 2 mock exams, 1 paper Wednesday and 1 paper Thursday. You have to put in the work to get the results. All right? And then Saturday, we do 2 papers again. More maths equals better maths every time. All right, next question. All right, don't need the calculator now. So this question is always some algebra, factorizing and all these things, right? This question says we have to factorize completely this thing. So here's just 2 terms. See the minus sign there, and oftentimes once I see the minus sign, I'm looking for the difference of 2 squares. Perfect square. But right now it's just common factors we have. What are the common factors in the numbers? 12 and the 4. Common factors is 4. It's going to put 4 as a common factor. In terms of the letters then, or the unknown quantities, the variables, you have an n squared here and you have an n here. Common factor of n squared and n is n. And this has an m in it, but this don't have no m in it. So m is not a common factor. So we're ready to factorize now. So it is like you divide this by that, 4m. So you can look at the number first. 4 into 12 goes 3. N into n squared gives you n. If you're not sure, you multiply this back by this again and you get that. Then it's like you have the negative 4, and divide by this 4, so you're going to get a negative 1. So put the negative. And then out of this mn, the n is factored out here, so we're left with the m. So you're left with the m. If you're not sure, you multiply this by this again, and you want to get that. So when you're not sure if your factorization is correct, you just expand it back. You have the test expansion again. But when you do the math a lot and gain confidence, you don't have to waste time. But you can't check everything in the exam. If you check everything you do in the exam, you're not going to finish. You have to work with confidence and gain confidence with practice. But that is it. And you check if this can be factorized any further. No. So that is it. It has been factorized completely. All right. Next part. The next part says you have to show that this thing is equal to that thing. So it's basically what they have done. They have taken this thing and they've written it as a single fraction. They've written it as a single fraction. So I'm going to call this the left-hand side and call this the right-hand side. So I'm going to show that the left-hand side is equal to the right-hand side. That's what we're going to do. So we're going to start with the left-hand side. That's how we can do a proof. So write out the left-hand side first, which is 1 over 1 minus x, and you're subtracting 4x. And I've elevated the 4x a bit because I want to turn this into a fraction. When you're adding numbers, whether they are algebraic fractions or numeric fractions, you want to make them relative. You want them to have the same denominator. So I'm going to turn this into a fraction with the same denominator as that. How do I do that? I take this one and divide it by the 1 minus x. But I also have to multiply it by 1 minus x. So I divide it by the 1 minus x and also multiply it by 1 minus x. Because I want the two fractions to have the same denominator. When they have the same denominator, they are said to be related. You can just add the numerators the normal way. And focus on your pluses and your minus. So ready now. So this one stays as 1 over 1 minus x. I'm just going to expand out this and see what it is. Minus, that's this minus between them. And this is 4x times 1, which is 4x. And then 4x times minus x gives me minus, well, they factorize the x. All right, no matter, all right, minus 4x squared. Maybe I'm doing it in too many steps, but no problem. Then now that we have that, they have the same denominator. It becomes a one single fraction with a denominator of 1 minus x. Then it becomes this numerator minus this numerator. So because we are subtracting, we have to be focused and concentrate on the negative signs. All right? Let me see if this is right, because something will look right as saying, oh, no, I make a mistake. This is not 1. This is x. This is not 1. This is the x. You see? That's another thing. You have to be able to see that something is wrong. Because when I look at it, this is something wrong. Because I know what I'm working towards. So this is not 1. It's x. So this is still x. So ready now. So you're going to subtract the like terms now. So it's x minus 4x. That gives me negative 3x. Negative 3x. And then in terms of the x squared, it is nothing. 0x squared over here. So nothing minus a negative x squared. Minus minus give me a plus x squared. Nothing minus a negative x squared. Minus minus becomes a plus. So I'm getting a plus 4x squared. And all you have done here, I want that space, make it a little smaller. All you have done here is basically switch these around. Switch these values around. That's all you have done. And then factorize the x out of it. See? So we can switch it around if you want and put this one in front, which is 4x squared minus 3x over 1 minus x. And then what they did, they factorize out this x. See? They factorize out this x out of these two terms. So if I factorize out the x now, out of this, I'm going to left with 4x. Out of this, I'm left with the negative 3. And it's all over 1 minus x. And that was shown. Because it becomes the right-hand side. So left-hand side is equal to the right-hand side. You can put that down here. If you never get it, you want to do it again. That's not the only way to do it, but that's a good enough way to do it. All right, let's continue. It says, hence, solve this. This hence means you have to use that result that we know. And what it is that this expression is equal to this thing up here. That we just show. So this equation that they're asking us to solve now, instead of leaving this on the left side, we're going to write this. So we're going to write this then as x into 4x minus 3 over 1 minus x equal to 0, equal this 0. Now listen now, simple. If a fraction equals 0, this is a fraction now, you know. If a fraction equals 0, it has to be that the numerator is equal to the 0. Has to be. Or look another way, if you take this denominator and multiply it over here by the 0, it's going to become 0 anyway. If a fraction equals 0, then the numerator is 0. So this therefore means that x into 4x minus 3 is equal to 0. That's what it means. And then if this product equals 0, then either this equals to 0 or the bracketed term equals to 0. So we can put this answer here. So it is either this x equals 0. That's one possible value of x. Or if the bracketed term is equal to 0, let's do it here. If the 4x minus 3 is equal to 0, what is the x? You carry over the 3, it becomes positive 3, and then divide under the 4. So the other possible value of x is 3 over 4. If this equals to 0, you carry over the 3, you get a positive 3, and then you divide under the 4. X equals 3 over 4. So those are my values of x. Nice and easy. All right, but getting those answers correct. Let's continue. If you never get it correct, you know what to do. Tomorrow, go back again. All right, let's continue. This one says you have to make V the subject, this V right here. And I always say to students, when you want to make something the subject, leave it where it is and transpose everything away from it. Leave it where it is in the equation and just transpose everything away from it. There's nothing wrong with leaving it on this side of the equation. And then you spin it around. So I'm going to transpose everything away from this V. First thing I want to move is that square root. The inverse of square root is to square. So it's like I'm squaring both sides. I'm squaring this side and squaring that side. And the square cancels that square root. But I don't have to write that. I can just write that as square both sides. When I square both sides, this side becomes p squared equals 5 plus vt. I'm leaving the v as a subject. I'm transpose this 5 first and subtract it. P squared minus 5 is going to be equal to v times t. Then I need to get rid of this t. I can take the t and divide it under this side, or I can say I divide both sides by t. And this one cancels this one. Same thing. Shortcut. Since the t over here is multiplying, I put it on this side and divide with it. So we get v equals p squared minus 5 all over t. But because I'm saying make v the subject, I want to put the v on the left side. I'm not going to rewrite this the other way around. I'll put the v on the left side equals this. P squared minus 5 over t. That is it. You guys who didn't do the paper, I'm not going to do the paper. I have to find time to do it. I never do the paper. I have to find time and do it. I have to find time and do it. If I'm in the middle of the night, get up 2 o'clock in the morning and do it. For the serious, that's what you guys do. When I was in school, if I miss a paper, I can't find a time in the day for do it, I get up in the night and do it. Get up 2 o'clock in the morning and say, all right, from 2 to 5, I do it. I get up 1 o'clock in the morning and say, from 1 to 4, I do it. But I do it. It has to be done. You can't find time in the day because you're busy. Go home, get an early sleep, set your clock, wake up, do it. You get back another hour sleep, wake up and you get your day. You're young. You all can do that. All right? You have to do the paper. If you're preparing for an exam, you have to do the exam. People who do sports, the thing they run is do high jump and then the triple jump. Ask him how much high jump you do before him go do, or 4 jumper champs. Go 4 or 5 jumps at champs. But think about 1 million high jump before him reach champs. Just about champ go do 4. Can one get 4 perfect jump and jump a personal best at champs. That's how it is. So you practice far more than you need to do in the actual exam. You go in the exam to do 1 paper, you want to do 25, 26, 30 papers. Because you want that one that you do in the exam to be perfect. So you practice all 30 of them. That's how it is. So you have to find time to do the papers. Next question says, the distance needed to stop a car D. This distance needs to stop a car D varies directly. That's a direct variation. As what? As the square of the speed S. The square of the speed S is S squared. That's a direct variation, so it's K times. So this variable is equal to K times this variable because it's direct. If the question was inversely, it would be K over S squared. D will be equal to K over S squared. But because it is direct, then the D, the first variable D, is equal to K times. The second variable is not S enough. It is the square of S, the square of the speed. So you have to read it carefully. They do that all the time, and some people can just put S alone when it's supposed to be S squared, because they said the square of the speed. Sometimes they even say the square root of the speed. And you'd have to put this. If they say the square root of the speed, you have to put that. Read carefully what they have said. Square of the speed is S squared. So this is a relationship they're telling us. That statement, that's what it means. The first variable D is directly proportional, very directly as the square of the speed, where the speed is S. It is traveling. All right. It says a car traveling at 70 meters per second. That's a speed enough. Requires a distance of 40 meters to make a stop. So what they're basically saying is that when S equals 70, the D equals 40. That's one pair of values they're giving you. That pair of values is often used to find your K. If you need to find the K. Not all the time you need to find the K. All right? But this is one set pair of values that they're giving you. Then it says, what is the distance? What distance is required to stop a car traveling at 80? So in other words, they give us this as one pair now, and they're asking for this now. They're asking for this. When the speed equals 80, what is the D? What is the D with the speed equals 80? So you have those two pairs. Now, this is the question we don't have to find the K. I have to do much like big people. If the question asks us for the K, we'll find the K. If they don't ask for the K, you don't need to find the K. So let me show you now what you can do to find the K. Make K the subject, and it will always be a constant. So what do you know? If you divide by the S squared, you're going to see that the D, I'm going to put it to the side. This equation means that D over S squared is always equal to a constant. That's what that means. The distance over the square of the speed is a constant. It is the same every time for any pair of distance and speed. What does that mean? It means that this distance that you want over this speed squared, using this one, this relationship for the K is equal to this relationship for the K. So we can set up like this. This one, this is the D that we're trying to find. So we're going to say D over 80 squared is going to be equal to the same ratio for this one. But the D in this one is 40. 40 over the speed for this one is 70. 70 squared. That is the equation. Because this equal K and this also equal K. We do the math like big people. So we can see they don't give a lot of space to solve these questions. So you don't have to be working on 1 million things to solve it. But understand that? Because the two of them equal k. So you just write to a k what equal a constant and set up the pairs that same way. This pair go together, and this is the pair that you want to complete. All right? So based on this now, to find the d, I need to use 80 squared and multiply it up here, so and work it out. So the d that I want is 40 over, let me shift this up. The d that I want is 40 over 70 squared, and then multiply this 80 squared up here, so times 80 squared. Whatever that gives you now is the answer. Quick and fast, nice and easy. Quick and fast, nice and easy. So it's a fraction, 40 over 70 squared times 80 squared. And that is 52.2. 52.2 meters. I have to give it in meters. And you give it to 3 significant figures. When the answer is not exact, give your answer to 3 significant figures if they don't tell you how accurately you must give it. Easy as that. Come on. These variations questions, these are questions we're supposed to get right every time. They're too easy. I forget them right every time. Some of them will ask for the K, some of them will not ask for the K. Whereas a direct or inverse, they will always give you. That finishes number 2. Somebody should have 18 marks already, you know. And the question is easy so far out of 30. So if you don't have 18, you don't have to do. Questions they get wrong. And watch over the video and do the questions again. All right? Let me see something. I don't think you may talk about recording and video. Make sure it's recording. Oh God. It's supposed to be recorded. Oh God, I don't know. Let me check. Oh my goodness. I think it's recording. I think so. Let me double check. Let me just double check that. Oh yes, it is recording. All right, good. Good. With this technology nowadays, I can't know any. I have to double check all these things. All right. Next question, number 3. All right. So this question says, the diagram below shows 2 pentagons. P and Q draw on a grid made up of squares. This is P, that one is Q. It says, select the correct word from the following list to complete the statement below. What's the statement? Pentagon P is something to pentagon Q. When I look at the 2 pentagons, I can see that they have the same dimensions. They just turn around. One just flip around. And I see the word congruent here. That is it, you know? You might be thinking rotate, but rotate is not there. Rotate is not a word. So, you know, you can't use that. They are congruent shapes. What are congruent shapes? Shapes that are equal in every way, but they don't have to be oriented the same way. They have the same angles and the same lengths of sides. To calculate perimeter, you get the same thing. Calculate area, you get the same thing. Right? Once they are equal in every way, same angles and the same length, same corresponding angles, same corresponding length. So see here, that length here corresponds to that length there. The tall length here, so corresponds to that tall length there. So this is a short piece corresponds to this is a short piece. This slant piece down here is that, and this piece out here is that. So the sides are corresponding. Then the angles are also corresponding angles. So for example, let's zoom it up some more. For example, you can say that this 90 degrees, these 2 90 degrees are here and here. Then this internal angle here, so, which is reflex, is equal to this angle inside here, so. Then this angle down here is the same angle here, and this angle up here is the same angle up here. And the same angle, same sides, corresponding 5 sides, and same corresponding 5 angles. So they are congruent. Congruent is just a fancy word for same, you know. It's a fancy word to say them are the same. Them equal. So that's the word that we want right here. Congruent. Congruent. It's not only triangles that can be congruent, guys. Congruent shapes. Any shape that are the same are congruent shapes. It says, give a reason for your choice. Give the reason for your choice. Because they have the equal corresponding sides and equal corresponding angles. Simply, that's it. They have, that's right, all sides equal, all angles equal. That's right, all sides equal, all angles equal. Simple. All sides equal, all angles equal. Done. One mark for it. All sides equal, talking about the length of the sides. All angles equal, talking about those angles equal on the two shapes. Done. 2 free marks that. Next question down here. So the diagram below not drawn to scale shows a pentagon VWXYZ. In the pentagon, YZ is parallel to XW. This one and this one parallel. Remember now, guys, once you have parallel sides, 2 things must jump out in your mind. Z angles and co-interior angles must jump out in your mind. The Z angles are equal, the Z angles are also called alternate angles. The co-interior angles, I call them the U angles. So for example, those 2 lines make a U now with this baseline. So it means that these 2 angles now, them add up to 180 degrees. Them 2 angles add up to 180 degrees. So you know that off the bat. Right? So since you know this one is 170, 114, you can work out that one. So we're nice. We're nice on this question so far. Then it says, another pair of parallel sides. YZ, YX, sorry, is parallel to VW. That's these 2 now. Also parallel. So since them 2 are parallel, again, you're thinking about Z angles, U angle, but we're not on Z angle here, so. But this line now join them, makes this and this 2 U angles. So them 2 angles here again add up to 180. They are co-interior angles again. So that's what this question is going to be all about. Those co-interior angles. And then because a pentagon with 5 sides, remember, a pentagon has n minus 2 triangles. Total interior angles is n minus 2 triangles. Remember that? Total interior angle, let me write out here, so. Total interior angle is n minus 2 triangles. Total interior angle is n minus 2 triangles. And a triangle has 180 degrees in it. So because this has 5 sides, the n equals 5. So it becomes 5 minus 2 times 180. That's the total interior angle, you know. 5 minus 2 triangles. So it becomes 3 times 180 degrees. What I work out to? 3 times 180 is how much? I'm working out the total in there. How much you get for that? 540 degrees. So I'm going to need this information. The total angle in there is 540. That's a pentagon. N minus 2 triangles. If you can't remember this n minus 2 triangle business, you can divide it up to, you know, what you can do. You can go so. Starting at this point, you can draw a diagonal across here. Draw another one across here. And see that there are 1, 2, 3 triangles. And each of them is 180. So if you don't remember this, you can do that little division for yourself. And it says 3 triangles there. And each triangle has 180 degrees in it. So the total angle in there is 3 times 180. All right. So let's go now. Boom, bang. It says determine the value. I would have to give no reason. Just tell them. This is not a give reason question. Right? So determine the value of WXY. Where is that? Right here. It's 180 minus this one because they are co-interior angles. I can maybe state it. This angle equal 180 degrees minus the 114 degrees. What that equal to? 66 degrees. 66 degrees. co-interior, because these two add up to 180. They are co-interior angles because there are angles in the base of those parallel lines. There are angles in the U. Touch a youngster there for me. Wake up, man. All right. Next angle I want is angle ZVW. Where is that? ZVW. Right here, the want now, you know. ZVW. To find that angle, I'm going to need this one. This one has to be 114 as well. This one has to be 114, you know. There are two reasons why it's on. Okay, look. The angle between the parallel line here. So the angle between the other parallel line there also is the same 140. Because the line underline the parallel. Underline the parallel. So the angle between the parallel lines must be the same, right? But also, you can go now and say that you have another U angle forming here. So these two angles are up to 180 as well. So this one up here must be 114. So I'm going to put it on the diagram that this angle is 114 as well. So if that is 114, I want to find this angle over here now. It's going to call theta. So you can reference it. You don't have to call it theta. It's going to be 540 minus the sum of these. See that? 540 minus the sum of those. And you can know, you know, remember them two add up to 180 already, you know. They don't have to include those two, right? Those two add up to 180. So the 540 minus the 180 there, and then minus the sum of these two gives you the theta. But go to that. All right, so let's go. And if you want to write out all of them, no problem. So this angle that I want now comes equal to the total angle. I'm leaving this on my paper. I'm leaving this calculation that I did over here in red. I'm leaving it on the paper. My examiner see me get the 540 from. So this becomes 540 minus the rest of them. I'm just going to put 180 for these two. 180. And I'm also subtracting this one, which is 114. And I'm also subtracting this 98 to get my answer. I'm going to put the 180 right here. So some examiner can see where I got this 180 from. That's these two is 180 degrees. And you work that out and you're good to go. What's the answer? How much? 140? 148 degrees. That's it. 148 degrees. All right, good to go. Next question. That's a transformation question. It says the letter A and a point C66 are shown. So this is the point 66 up here. I mark it in red. So it becomes glaring. This is the point 66 up here. And that's a letter A. All right, that's a letter A. It says, on the diagram, draw accurately each of the following transformations. An enlargement of the letter A of a scale factor of 2 about the point 66. So remember, if this is the center of the enlargement, we can't use the enlargement matrix 2002. Can't use it. The enlargement matrix, because the scale factor is 2, is only for when the center of the enlargement is the origin. That's when you use that matrix. So we have to construct this enlargement. We can't calculate it. We're going to construct it. So since the scale factor is 2 and the center is 66, all it means is that the distance of the points on the A from the point 66 is doubled, because that's what a scale factor of 2 will do. Double the distance. The size of the A is going to be doubled in size, you know, but to construct it, you double the distance of the points from the point, the center point. Let's look at it. So let's say I'm doing 1 point at a time. I'm focusing on these 3 points, and I can fit this one in it afterwards. This line I can fit it in afterwards. The size of the A is going to be doubled because of the scale factor of 2. Watch this now. Let's do it in blue. Pay attention. If you never get it, you have to get it now. This distance from here to here is going to be doubled. It is 2 diagonals that come across. So you have to go across 2 more diagonals to get it. So it's coming down to here. So another way you can know, another way you can double it, that distance, this distance that we want to double, is if you break it down into vertical and horizontal movement, right? You can say 2 down, 2 across to get it. So to get another one of that distance, you got 2 down, 2 across again. So it's coming to here. But you can just look at it and see that it's 2 units across the diagonal. From here to here is 2 units across this diagonal. So you're doubling that distance, you got 2 more across the diagonal, it's coming to here. That's where this point is going. Mark it in red. That point is going there. I'm going to leave the blue line as my construction line. That point is going to there. Then this one. This is the distance from the center line. That distance is going to double as well. I'm going to break it down this time. I'm not coming straight across the diagonal. So it's 1, 2, 3, 4 down, 1 across. So that this is going to double. So like you do another 4 down, 1 across and go to extend. 1, 2, 3, 4 down, 1 more across. So it's coming all the way down to here. That point is coming down to there. So that line, this line, is extended down to here. Now, if you do it on graph paper, you can actually extend and see that this is double now to there. So this point is coming down to here. So I'm going to mark that point in red as well. Now, once we have the point, I'm kind of good now, you know. When I have to do the other construction, you know, I don't have to do this one, you know. I can use my common sense now. I don't have to do this one and expand this one down again, you know. I don't have to do that one. Look how I can work it out now. Since this distance between these 2 points was 2 units, the scale factor of 2 is going to make it now 4 units. So the point here is going to be now 4 units from here, the corresponding points. So it's 1, 2, 3, 4. It's coming to here. This point is coming to here. But if you extend it all the way down, you can see there, coming all the way down to there. So it's like this distance from here to here is doubled and it come down to there. But I'm saying I did not have to do this one that I just did. I did not have to do that. Since this base or this size of the A, the base of the A was 2, it's now going to become 4. So that point here must come right here. But the scale factor is going to double the size of the A. So I'm going to put in this point now here. So those are the 3 points of my A now, my enlarged A. I'm going to draw it in red. So that's my enlarged A. Then this is a cross piece now on the A. It was 1 unit from the top, almost a unit. Let's zoom it up. Not fully a unit, you know. But it's almost a unit from the top, and you take off a piece. So it's supposed to be almost 2 units down from the top then. So it's going to come to about here. So that cross piece is going to be about here. So I watch this now. You see how far this is from this circle, everything important. So how far, you see this is a gap right here, so that gap is also going to double. That gap right here, this is a gap right here, is also going to double. All right? So it's going to be maybe around here. That line is going to go. Because the original one was be about there. It is now doubled. The gap is now doubled to there. That's my enlarged A. I'm not going to put on this line, you know. I'm not going to put on this line. It's going to be wrong if I put on that line. That's my enlarged A in red. And I'm leaving those blue lines as my construction lines. But go to that. If you never get it, go and do it. But that's foolishness. All right, that's my enlarged A right there. All right. Next question says we are to do a translation -3 of the same A, -3, 2. Let's do it in a different color. Now, this -3 is the horizontal movement. This 2 is the vertical movement. So this translation is going to move the thing 3 units to the left. That's what the negative stands for. And 2 units up. 2 units up. So any point is going to come up here. That's what it's going to do. Move a point. All points on the A is going to move 2 units to the left, 3 units to the left, and 2 units up. That's what this -3 stands for, the horizontal movement. Because the negative is going to the left. And then this 2 now is a vertical movement because the positive is going up. So you're moving each point 3 units to the left, 2 units up. I just need to move 1 and then draw by the same A in place. Common sense. So let's move this one alone. Let's move this one. Let's do this part in purple. So I'm using this point to see where that point will go, and then I can draw him by the same A. So this point moves 3 units to the left. 1, 2, 3, and 2 units up. 1, 2. So this point is coming right to there. That's where it is going. 3 units to the left, 2 units up. That's where this point is going. So what I can do now, since I know that point, I can now draw by the A, same size A, around this point, using this as that point, corresponding. So to get to this baseline, they come down to go 1 to the left. So I will come down to go 1 to the left. So that's another point on it right there. And then the width of this base across here was 2 units. So put it across here. So 2 units. See there? That's where the A points on the A are. That's the image A. Because the same size, translation don't change the size. And there's this little piece across here now, put it back the same place where it is, just above this halfway line. I'm going to put it back here, just above this halfway line there. Everything important. Not putting it on the line, guys. It's not on the line. Don't put it back on the line. That is it. Argument done. But all right? All right, beautiful. And that question done. Question done. 9 more marks. So I get 10 minutes to get because an average mark is about 10 minutes, about a minute. Honestly. You get 10 minutes each for these questions. Each of them carry the same number of marks. So each of them get the same amount of time. But anyway, next question. This question now is a functions question. All right? They give us this one function. This is the same as f of x equals 3 minus 2x. You know? So don't make this fancy thing complicated. Just says f is a function such that x maps onto 3x. 3 minus 2x. So x maps onto f of x using 3 minus 2x. And the first thing I want us to calculate here is the value of a. Easy. This a is what this becomes when you plug the -1 in it. Because it is f of -1. Because the -1 is mapping onto a. So you can write it here. The a becomes f of -1. When you plug the -1 in the function, it becomes a. So it becomes 3 minus 2 times -1. That becomes 5. Becomes 5. And you can even look at the numbers because it's a linear function in it. It's a linear function. And realize that the values decreasing by 2. Decrease by 2. Decrease by 2. Decrease by 2. That's a linear function. Keep decreasing by 2. That's why you have the -2x right here. Right? It's just like on a graph. So this has to be a 5. So the a equals 5. See the a equals 5. And that's more work for it right there. A equals 5. Easy. Next part says, determine in simplest form the inverse of f. What is f again? 3 minus 2x, right? 3 minus 2x. So I'm going to start by saying f equals 3 minus 2x. I'm going to inverse it. When I inverse it, the f becomes x, because that's the range, it becomes domain, equals 3 minus 2 times. This x becomes f to the -1, the inverse function, the range in the inverse function. Then I'm trying to make this thing the subject. This time, because it is negative, I can bring it over here and make it positive. And then take this x and bring it over here, so I make it negative. So I would get 2 times f to the -1 equals 3 minus x. Then to leave the f to the -1 as a subject, I need to divide by this 2. You can say divide both sides by 2 if you want. Same difference. So we're going to get f to the minus 1 equals 3 minus x over 2. Now that we're done, we can put in back the of x right here. That's it. Some teachers use y. I would have put y right there. So if we do it that way, then no problem. And I would have y right there. So if we do it that way with the y, same difference. That is it. But good. Class is much harder to be in when you don't do the work, you know. You just have to do watching. When you do the work and you're actually marking something and making corrections, that's much better class. That is why you need to do the work before the class. You need to do the paper. So when I send the paper in the group, you need to do it. That's why I send the paper in the group for those who are not here. So Brian wasn't here and do it. Let them do it. You do it. All right. Next question. They want the composite function f squared. Now remember, guys, f squared don't mean that you're squaring the function. It actually means f of f. This actually means f of x. You have to remember that. It don't mean that you're going to square the function. So you put f back into itself. Let me write them out for you. What was f again? 3 minus 2x. So it's like you have f of x equals 3 minus 2x. And you also have f of x equals 3 minus 2x. And put them a little bit lower for illustration purposes. And then this means that you're putting f into f. You're putting f into f into itself. So like you're taking this f, and you're bringing it and you're putting it into the other f right there, where the x is. That's how you form the composite f of f squared. That means f of f into f. Right? So that's how you construct the f squared, which is f of f. And so the f squared of x, which is same as f of f, is equal. I'm putting this on my exam paper. You see everything I'm doing on the sheet? That's what I'm doing in the exam room. You know? What I do on the sheet is what I'm doing in the exam room to get my marks. All right? So f squared now is going to become 3 minus 2 times. And where this x is, I'm going to put back all of the f there, which is 3 minus 2x. But the question says the composite. Well, this is the composite. And actually helping you by telling us the composite. If you leave that, yeah, but most times you have to simplify your answers. So I'm going to simplify this. So when I multiply this negative 2 times 3, I'm going to get negative 6. And it's going to be 3 minus 6, going to give me a negative 3. Then this negative 2 times this negative 2 is going to give me a positive 4x. And that's it. Negative 3 plus 4x is the answer. Same as saying 4x minus 3. Same thing. This and this is the same. But that is it. Everybody good with that? Online, everybody good? You all still there?
Yes, sir.
All right, beautiful. Sure. Oh, Lord. All right, so far so good, guys. Let's continue. Down here now says state the value of this. But the answer for this is just negative 2, you know. Because a function and its inverse, reverse is a mapping. You don't have to work this out. So whatever the inverse does to 2, look at it. Whatever the inverse, because remember, you know, you see this, it means the same is the same as f of f to the minus 1 of negative 2. So it means that you're doing the f to the minus 1 of negative 2 first. But these f and f to the minus 1, they are inverses of each other, you know, they reverse what each other does. So whatever the f to the minus 1 does to the negative 2, the f is just going to reverse it and bring it back to negative 2. So this don't need no calculation. This just equal negative 2. You know, waste the time and show no calculation. Because it's 1 mark theta, CSEC expected to know that. Because the function and its inverse does the same thing. Even if they had these the other way around, like so. And they had it f to the minus 1 of f of negative 2. This will still be negative 2. In fact, f to the minus 1 of f of any number a is going to be equal to the same number a. Because the function and its inverse, they reverse what each other does. So if you apply one function and then inverse it back, it's bringing it back to where it was. If you apply the inverse and you apply the function and the result, it's bringing it back to where it was. So then the answer for this is just a negative 2. All right, so I'm not going to do any work. If you want to waste time and work out the inverse and then work out by the f, waste of time. It makes no sense. You must know stuff like this. All right, let's continue. Then we'll come to this part now, which is some coordinate geometry business and some linear programming in this one. It says, use a ruler to draw the line x equals half. Remember, x equals half is going to be a vertical line. Remember, the y-axis is actually x equals 0 now. So x equals half is going to be vertical like the y-axis and pass through half. Let's draw that one first. Them say must use a ruler. I don't have any ruler. So 1 here, so this must be a half. So I'm going to draw it right here. This line is x equals half. So I'm going to draw it the best way I can. But I don't have any ruler. All right. This app that I use and don't draw straight lines for me. I need to get one that does. So when I find an app that draws straight lines, it kind of limited in some other way that I want, with what I want to do. So this is the line x equals half. X equals half is this line, this vertical line. And put the y equals 0 over here for the y-axis. X equals 0. So this line is x equals half. X equals half. Then I want y equals x, another easy line to draw. Y equals x passes through points where the x and the y value is the same. When the scale is the same on the y-axis and the x-axis, it passes right down the middle of your graph. So it passes through points like 0, 0, 0, through the origin 1, 1, 2, 2, 3, 3. Pass through all those points where the x and the y value is the same. So using the ruler to draw that straight line. Some people doing this and just draw one random line up like that. No, don't do that. Make sure the line that you're drawing pass through the correct points. Must pass through the correct points. So it's going to go right down the middle of the graph like this. Farzan, pay attention. I'll send the video to your mother. I'm share me a call every minute. You know? Until I reach part of the video. When we reach. Until I reach part of the video she must watch. You can do that, you know, tell her exactly which part of the video. Let's see. Minute number. Have it. Pay attention, man. So draw the graph right down the middle here. You're gonna do it with a ruler now. Don't draw it friendly like me. Questions I use a ruler. Alright. I must label it. Label it, you know. When you draw the lines, you label them. Y equals x. Then one line, x plus y equals 5. Another easy line. X plus y line. Gonna cross the y-axis at 5 and cross the x-axis at 5. You must know about the x plus y lines. See it here? X plus y equals 5. It pass through 0, 5 on the y-axis. And it pass through 5, 0 on the x-axis. So it pass through this point up here, so. And also pass through this point down here, so. So if you have your ruler, just line up those 2 points. This point and this point to pass through. X plus y equals 5. We pass through points with x and y value add up to 5. So it pass through 1, 4 right here, so. It pass through 2, 3 right here, so. It pass through 3, 2. It pass through 2.5, 2.5. Yes, so. No, 3, 2 right here, so. Wrong place. It pass through 2.5, 2.5 there, so. It pass through 4, 1. See it? Pass through all those points. But you only really need these two now. You line up a ruler and get it, right? But I'm doing it with all these points because I don't have a ruler. So basically, you draw the straight line through these points. That's the x plus y equals 5 line. I know something. What's the matter with you? All right, let's go again. Better. X plus y equals 5. Label it. Label the line with the equal sign. X plus y equals 5. leaving it down there. So those are the lines. They're going to ask us for some region next. Right? So I draw the lines, then down here, so no. Pay attention now. So then say us on the grid, label as R the region where X is greater than or equal to a half. This means above this line, above. X equals a half. So it means that we're going to the right of X equals a half. To the right of this line, X equals a half. I'm just putting it there. Then this one now is above again, but that is why greater than or equal to X. So we're going above this line again. So for this one, we're going above Y equals X. Why is it? Because the greater than means above when the Y on the left side of the inequality is positive. So we want to go above the line Y equals X. So this is the line Y equals X right here. We know that we want above that line. So we'll put the arrow pointing up. So the region I want is above this line. And also above this one, to the right of this one, so far. So far, we're looking like we want somewhere inside here, right? Let's look now at the last one. The last one now wants below this one now. This one. So because the Y over here on the left side is positive, the less than means below. When the Y on the left side of the inequality is positive, less than means below. So we're going below this line now, below the line X plus Y equals 5. So that line is this one. I'm going to put up arrow pointing down. I want below this line now. Put in red. Below this line. So the region I want is below this line. So the common region is here. This inside this one, below this line, above this line, and above this one. So the region that we want is inside. I'm going to put the R in here. So put the R in there. That's it. That's where I want the R, right in there. Satisfy all three inequalities. I'm leaving these arrows on my diagram as well, and I'm leaving them. I put in my R, so I'm good. That's where the R is. But good at that? Nice and easy. Next question, please. Number 5. Statistics. On-group data. But the data is on-group. The hardest set on-group data questions. Hardly. This question says, 60 students took an algebra test, which comprised of 15 multiple choice questions. The number of correct answers that each student obtained is recorded in the table below. So look at it. You have to know what is the frequency and what are the scores in it. The number of students are your frequency. This is a F. And the scores that they got is your scores. So these are your scores. These are your frequency. You put that in to make sure. Now these are the number of students. They must add up to 60. They say 60. I'm putting it there so I don't forget. If you want, you can check it and make sure it adds up to 60. Because if you do foolishness sometime, you know, and make it all add up to 60. But it's supposed to add up to 60. All right? So these are the scores. It is on-group data. What does this mean? But 6 persons got 8 marks or 8 answers correct. 14 persons got 9 answers correct. 2 persons got 10 answers correct. 10 persons got all 15 correct. So 10 persons got everything right. All right? Let's go. It says, use the table to determine the number of students who got 13 correct answers. So it's 13 correct answers here. 11 students got 13 correct answers. 11 students got 13 answers correct. 13 answers was obtained by 11 students. 13 correct answers. Next question. The modal number of correct. Remember, the mode is a score that corresponds to the highest frequency, or the score that most persons got correct. So looking for the highest frequency. The highest frequency is 14. That score matching 14, what 14 persons got was 9. So most persons got 9 correct. So the mode is 9. The score that matches the highest frequency. So I'm just going to write the 9 here. So 9. 9 correct answers. I could just write 9. Or the mode equal 9. Just write 9 and get the marks. Just put on 9 on the paper and they give you the marks. Not for write total of this. Just write the 9. Next one. The median number of correct answers. So remember, the median is the number of correct answers that will be in the middle of the distribution in ascending order. No, the table have the correct answers in ascending order. And there were 60. There were 60 students. And these are the students. Now, I would say to you, you can put in a counting column, which is a cumulative frequency column. But you don't actually need it. What is now? I also told you that when the data is ungrouped, the position of the median, put it in red. You know, says since it's 60 students, like I take the 60 students, right? I divide it 30 and 30. 30 over here and 30 over here. Right? So the median, since it's an even number of students, the median is going to be a value in the middle. So it's the average of the 30th and the 31st. You're going to average them. The 31st score and the 30th score and the 31st score. Those are the two scores in the middle. You're going to average them. But calculation can tell you what value that is. Is it like this? See, you know, the position of Q2, that's the median, you know, when the data is ungrouped, is half of the n plus 1 term. Remember that? That's why we revise, so you can remember if you never remember before. The number of values is 60. So it becomes half of 61. Half of 61 is 30.5. 30.5 term. What 30.5 mean? Halfway between the 30th and the 31st, as I just did a while ago. So you want to find the 30th value and the 31st value, and you average them. All right? So see here now, Q2 become the 30th value plus the 31st value over 2. So how do we find the 30th and the 31st value? Because what you can do now is count the number of values down here until you reach 30 and 31. You have to know which score corresponds to the 31st, the 30th, and which score corresponds to the 30th. So you finish right here, so you have 20 values already, don't it? So you have a counting column. Let's put it in a counting column. Counting. And your counting is your cumulative frequency. You're adding up the frequency. I'm doing it for you. So when you finish the first persons, you've gone 6 persons. They add 40 more persons, so you have 6, they have 20. You have 20 persons when you finish this set of values. They have 2 more persons who got 10, so you reach 22 persons. When you finish all of these, you reach 22 persons. Then you finish this step, now you reach 28. You reach 28 persons. After you finish all of these, you reach 28 persons. And you have these other 2 persons to put in, you reach a 30th person. Or the 30th student. So the 30th student got a 12. See that? So the 31st person must be one of these 11 persons. The first of these 11 persons is the 31st person. So the 30th person, the 30th score is at 12, and the 31st score is at 13. So these are those values. Okay, you reach 30 persons here, so when you finish all of this, you reach 30 persons. So the 31st must be one of these. The last of these persons is the 30th one. So the 30th person got 12. And the 31st person got 13. So you're averaging 12 and 13 for the median. So this becomes equal to 12 plus 13 over 2, which works out with 12.5 answers. So the median is 12.5. correct answers. Average them. Touch a youngster for me. Sit up, man. Sit up. Sit up. Sit up. Sit up, my boss. That's why I have to do the paper. When you do the paper, you have something to write, you have something to check, you have vested interest in what we're doing. Right? But you want to see what the correct answer is. You want to see if you're right. So you have to do the paper before you don't come to the class. Do it in the night or something. Find some time to do it. I know that everybody busy. I know that you don't have classes. I know. You have to use up the nighttime hours. When you have exam, night is not just to sleep again. Night is to do what you can't do in a day. Cut your sleep. You only need to sleep 4 hours. You're young. Sleep is a concept. When exam time comes, you only need to sleep 4 hours. You have to learn how to operate on 4 hours sleep. You sleep 8 hours 1 day for the week. 1 day for the week. Like tonight, you sleep 8 hours going into tomorrow, because school tomorrow. Only need 4 to 6 hours sleep. You don't need not 10 hours sleep not till exam done. When exam done, you sleep in 8 and 9 and 10 hours. You know, some people are sleeping at 12 hours and 15. Now waste time. Wasting time, sleeping so much. Hey, when I was school, I pride myself and studying through the night. You know. I know some of my friends are sleeping. You know. All them are get higher than me. Them can't get higher than me. And them are sleep when I study. That's why I mean to come first. And when them are sleep, I study. 4 hours. It was my standard. 4 hours. I sleep more than 4 hours. When my friend them are sleep, I study. All them for beat me. Them can't beat me. They couldn't beat me. And when I study, them asleep. Anyway, let's continue. That was me. Next question says, the probability a student chosen at random had at least 12 correct answers. At least 12 means 12 or more. It means greater than or equal to 12 correct answers. You want to know how many students out of the 60 got 12 or more, right? Let's look at it on the table now. So 12 years or more corresponds to these students. What that add up to? This is 10, well, this is a 20, and 10 make that a 32. That's a 32 students. Got 12 or more. So that this is a 10, this is a 20, you know, 20 and 10 are 30 and 2, 32. 32 students got 12 or more. So I'm just gonna write it here. So. And I can leave these marks on my paper now. These marks that I'm putting on my paper right now. 30. I found the 31st right in there. I'm leaving everything on the slip on the paper right there. So I'm not erasing all these markings here. These are a circle I put there, so I'm not taking them off. It's a part of my answer. The examiner can see where I get my values from. You can see it. So I'm going to put the 32 of that thing down here, so now. 32 out of 60. I'm going to leave all that on the paper to you. I'm not take it off. 32 out of 60. 32 out of 60. And I can reduce that. That can divide by what? 4. If you divide it by 4, much we get 8. If divide it by 4, we get 15. Carry down to lowest terms. That's it. That's it. Anything else? Question out of a part B. All right. That done. Next question. Pie chart. Remember, this can do like a ratio question. A lot of the questions can do like ratio and proportion. I like ratio because all you have to do with ratio is multiply and divide by values to get what you want. You get me? This question says, a group of students wrote a physics exam. Each of the students achieved a grade 1, 2, 3, or 4. It says the pie chart below shows the results. And this is where the information is most telling. That 117 degrees represent the degree out of 360 that got grade 3 And there are 39 students corresponding to 117 degrees. So I can automatically know what the total number of students is from that. And the total number of students represent 360 degrees. So I can set up a ratio. 117 degrees correspond to 39 students. 39 students. And 360 degrees correspond to the total number of students. So all I need to do is take this ratio and build it up to 360 degrees, and I will know the total number of students. Easy like that. But let's see what I want us to do. Let's see what I want us to do. This is me getting ahead of the question. That's what I asked for the total. See there? Determine the total number of students who wrote the exam. There are multiple ways it can be done. I'm going to do it 2 ways for you. I'm going to do it by saying, okay, this out of the 360 of the total is 36. Look at it this way. The 17 degrees, 117 degrees out of 360 times the total number of students is 39. Now look at it that way. I'll put another way. Another way. Watch this now, another way. 39 students out of the total number of students. I don't want to confuse you. Let me do it by the other way I was doing it. All right. So it's 117 degrees out of the 360 degrees times the total number of students. This is a ratio of total number of students. That is 39 students. So from this, you can calculate what the total is. Just multiply by 360, divide by the 117, and I get the total number of students. That's 39 times 360 over 117. That gives you the total number of students. Let's work it out with the calculator here. So I'm saying 39 times 360 over 117, 120 students. Look at it, you know. I'm saying the fraction of the 360 of the total number of students is 39, because the 117 represents the fraction of 360 degrees, that is 39 students. Put another way, you can set up like a ratio, as I said. So this is an OR method now. OR. Doing it as a ratio. So I'm going to get the same thing. We can say as a ratio, 117 degrees corresponds to 39 students. 360 degrees correspond to the total. So I want this side to become 360. I want this side of the ratio to become 360. So what we can do, we can divide it by the 117 first. So divide both sides by 117. Bring it down to 1. Then after I bring it down to 1, to get it to become 360, we now multiply by 360 times 360. Multiply the side by 360 as well. So we divide both sides by the 117 to bring it down to 1, and then multiply back by 360 to bring this side to 360. So the 360 degrees know that this side is equivalent to the total number of students, which is going to give me also 120 students. So the answer is 120. If we write this out, we're going to get the same 120. Same thing we did over here. That's another way to look at it. So total number of students is 120. That is, total is 120. Total is 120 students. Sometimes simple things are hard to explain, but that is it. We like a ratio. All right. Next part now says ratio. All right. So look here now. All right. So this is 120 students total, right? And you have 39 of them over here, all right? So 39 students are over here, means that them 3 years, so put it in red. It's a them 3 years, so add up to how many students? 120 minus 39, don't it? 120 minus 39. How much is that? 81 students. See that? So over here between grade 1, 2, and 4, there are 81 students total. That information can be useful. All right, let's see what this is now. 81 total. It says the ratio of the number of students who achieve 1, 2, and 4 is in this ratio. 2 to 4 to 3. So the 81 students is in this ratio, you know. 2 to 4 to 3. The 81 students that get grade 2, grade 1, 2, and 4 that we just calculate, they are broken down in this ratio. It says a student pass exam if he gets grade 1, 2, or 3. Determine how many students pass the exam. So what I want to know now is what grade all the students got. Look how we're going to do it now. We're going to do it as a ratio question. So what is now? Grade 1 to 2 to 4 is 2 to 4 to 3. 2 to 4 to 3. What is now? Because I know the actual total number of students is 81. I'm going to put in a section now for the total of this set. Total of this set. Let's just call it set. Let's just call it set. This set total. Set total. Total of this set. And this set total here would be 9. See it? Is 9? Yeah, 9. 7 to 9. This set total would be 9. But the actual set total is 81. That's what we just say up here, so you know. The actual total is 81. So to know what the actual numbers are, I want my actual set total to be 81. So we therefore have to multiply this ratio by 8. By 9, because 9 is 81. Multiply this by 9 for the actual to become 81. So I multiply everything by 9 to see what the actual numbers are. So when this becomes 81, multiply this by 9, I get 27. I don't know the actual values now. This becomes 27. Multiply by 9. Multiply this by 9. So let's put the times 9 over here. So let's put the times 9 here. So if I don't have a lot of space. So we'll put the times 9 over here. So sorry. I'm going to multiply by 9 because I want this to become 81. So multiply by 9. This becomes 81, which is the actual total of that group. This becomes 27. This becomes 36. And this becomes 18. So these are the actual number of students who got these grades now and now. So if I want the students who pass, is the students who get grade 1, 2, and 3 now. So see you know, grade 1s, grade 2s, and grade 3s. How many students get grade 1? See here, 18. How many students got grade 2? 36. How many students got grade 3? It was 39 from up here. So see there? Grade 3 was 39. 39. And you add them up, you get the total. You get the total. Put it here. So the total number of students who pass. Grade 1, 2, and 3 are the ones who pass, right? So passed. Add up these. You get who pass. So it's 18 plus 36 plus 39. 93 passed. And so who failed here? 27 failed. So you could get it that way as well. 120 minus 27. You get 93. Because all of these fail. The person who got grade 4 failed. So you put the 120 minus 27 and get that as well. That is it. So 93 persons passed. Whenever it's question right, go and do it again. All right? like ratio question. Okay, just multiply and divide it by values to get what you want. That is all. Remember, this part of the ratio I added, I added this part of the ratio because it was relevant information to me. This part of the ratio was added. And put a different color. Put it in purple. Right, so that part of the ratio was added to it. It was not given. Because the total, I added it to it so I can work with it. I put in the set total for those who get 1, 2, and 4. All right, next question says, determine the value of the angle in the pie chart represented by grade 1. So grade 1 was 18 persons, right? Out of the 120. So the angle in the pie chart is going to be 18 out of 120 students times the total angle in the pie chart is 360 degrees. That's a fraction of the pie chart that will be occupied for grade 1 students. You work that out to get the answer. 18 out of the 120. So it's 18 over 120 times total angle in the pie chart is 360, 54 degrees. 54 degrees will be used to represent the people who got grade 1s because 18 of them got grade 1s. All right, that's that. So this question was very important to know the grade that each person got, or the number of persons who got each grade. So I use this ratio that they gave me, and knowing that the ratio total 81 in actual numbers, I work out what the values are by extending that ratio to 9 and see what I have to multiply to get what the actual number is. So these are the actual number of persons who got those grades. All right, that finishes that question. Next question, number 6. Number 6. Number 6 says we have to take pi as 20 over 7. So once you see that, you know we're going to do some circular measures. Once you see pi as 20 over 7, we're going to have to do some circular measures. Question says the diagram below shows a rectangular tank. The base is 50 by 40. That's here, 50 by 40. And it is used to store water. The tank is built to a depth of 15. So it has 15 in it. First question, what is the volume of water in the tank? Easy. Length times width times the height of the water. Or the cross-section area of the base times the height. Same difference. So it's 40 times 50 times 15. And the answer there is in cm cube. When you work it out. Nobody worked it out? What I get? How much? 30,000. 30,000. All right. 30,000 looks correct. Okay, this one is at 20. Yeah. All right. That is 30,000 is the volume of water. And make sure you write cm cube, right? Cm cube. Next part says the cylindrical container below, shown in the diagram below, is used to fetch more water. So it have 30,000 there with it. Needs used to fetch more water to fill the tank. It says a container which is completely filled, that is this container is completely filled with water, has a radius of 20 centimeters, as you can see there, and a height of 21. Height of 21. It says all the water in this container is added to the water in the rectangular tank. Calculate the total volume of water that is now in the rectangular tank. So want to see what volume that is? And add on the 30,000 to it. That's all. What is the volume in this tank? Let's work it out to the side. I can ask us for it. What's the volume in this tank? Volume in a tank, cylindrical tank, is pi r squared h. Area of the base, which is pi r squared, times the height. That formula is given on the formula sheet, but these are things you should know. The volume in this tank is the area of the base, pi r squared, times the height. They said the pi is 22 over 7. That's the volume in the tank. 22 over 7 times the radius is 20. So that's 20 squared. And the height is 21 times 21. That's the volume in the tank. I'm going to add that to the volume in this. That's the volume in the cylindrical tank. Put VC for cylindrical tank. VC. VC for the cylindrical tank. They have a rectangular tank. Work it up here is this. Let's call it VR for volume in the rectangular tank. VR for the rectangular tank. What is work out to know? 22 over 7 fraction. 22 over 7 You're multiplying that by 20 squared to get the area of the base, and you multiply that now by 21 is the height. 26,400. 26,400 centimeter cube. All right. So you're adding that to the what was there before. So the volume in the rectangular tank, no, the volume in the rectangular tank, which is a new volume, is 30,000 that was in there before, plus this 26,400 now. What I work out to? I work out to 56,400 centimeters cube. That is the volume that is now in there. Are you okay with that? Good. That's a new volume after we add some water in there, right? So we'll put this amount in there. All right, so we work out this on the side. I'm leaving this on my paper to show I get the volume in the cylindrical tank that was now added to the rectangular tank. Next part now says, show that the new depth of water is now 28.2. The new depth of water in the tank is now 28.2. So let's look at the tank up here. So when you add this tank and they add some water in it, you go to a new depth up here. A new depth. Let's call that new depth D. But that new volume is what we just calculated a while ago. 56,400. That new volume is now 56,400 cm cubed. So what it is now, the base area times this depth is now equal to 56,400 to get the new volume. So the new volume here in red. So I want to know what the new depth is. So that new depth, the new volume is 56,400. But how would we calculate it? The area of the base, which is a 40 times 50 times the new depth, is going to be equal to the new volume. So that's how we can calculate it. I could do the volume divided by the area of the base. Can do it that way as well. But let's work it out that way. So I'm going to work it out here and then copy it down. So this is what we're going to do. We're going to say the 40 times 50. The 40 times 50 times the new depth is going to be equal to this 56,400. Shift it over. Shift it over here and put it up here. So it's going to be equal to this 56,400, this new volume. And then to get the D, we're going to take this and divide it under here. Let's copy this down. That's what we're going to get to a new volume. So I'm showing the work up here. Let's paste it down here. So let's paste it here. All right, let's put it back in blue. Right, so to get this depth, we need to divide by these values, right? So the new depth, come on. The new depth D is going to be 56,400 divided by the 40 times 50. So that new depth is going to be what? It's going to be 56,400 over 40 times 50, the area of the base. See there? You get a 28.2 centimeters shown. See? You get it. 28.2. So it increased by how much? It increased by, subtract 15 from that to how much it increased by, right? Watch this part now. This part says no, the vertical height of the tank is actually 48. The vertical height of the tank is actually 48. Determine how many more cylindrical containers must be poured into the rectangular tank to completely fill it. This can be done multiple ways. It can be done by working with the volume that we have to put in there by knowing what the total volume of the tank is and divided by the volume of one of the circular tank to know how much total you need to put in there to fill it up, right? So you can know the total volume to fill it, require left to fill it. But what you can do to work this out is know what the increment is for each time you put a tank in there. Each time you put a cylindrical tank in there, what height it increased by. All right, so look at it this way now. So the total height is that. So the total height to fill. All right, let's do it step by step. So each container raise the height by how much? Each container, I'm just trying to find a way to set it out. All right, let's call it each fill equals 28.2 minus 15 centimeters in height. What will that work out to? Sorry. Each fill is 13.2 centimeters. So each time you fill it, it increased by 13.2 centimeters. But understand that? Okay, it was 15 centimeters first. It was 15 centimeters in there first. And we raise it to 28.2. We'll put one tank of the cylindrical arm in there. So each time we pour the cylindrical container in there, it increased by 13.2. Increased by 13.2. So the question is, it is at 28.2 now. How much further I need to fill? So it is now required to full is 48 minus how much it reach now. Because I say how many more we have to put in? Minus 28.2. What is work out to? That is the amount required to full it. How much time I have to fill it? How much is this? What is this work out to? What height we need to fill it by? What height required to fill it? So it's 48 minus 28.2, 19.8 centimeters required to fill it, to full it. Remember, each time you full it, at this amount you put in, so there's only one a little bit more you actually need, So number of fills. Just say each time you pour one in, there's a number of fills. It's going to be this amount that you require to full it, which is 19.8 centimeters, divided by each time you full it is that you put in there, 13.2. What that work out to? So it's 19.8 divided by 13.2. That's 1.5. So what question says? Determine how many more cylindrical container of water will be poured to fill it. 1.5. 1.5. That is 1.5 more tanks. 1.5 more containers. Guys, you understand the reason behind this? Understand the reason? Let me explain it one more time. I'm explaining it from the perspective of the height that is moved. Because every time, because the base area of the cylindrical, of the rectangular container is the same. Every time you full it, it's going to increase the height by the same amount. Right? The height is going to move by the same amount. Now, each time you pour one of the cylindrical container into this rectangular container, the height is going to increase by this. Because remember, it started out at 15 centimeters. And when we poured one of the cylindrical tank in it, it moved to 28.2 centimeters. So it means that one container of the cylindrical, one of the cylindrical container increased the height by this amount, by 13.2. But the overall height of this rectangular tank is 48. And it is already at 28.2. So the height left to full it completely is this 19.8 centimeters in height left to full it completely. And if each of the cylindrical containers is going to move it by 13.2, to know the number of times it's going to move by 13.2, you divide the total by the 13.2, and it tells you that is 1.5 times. You're going to have to full it for it to reach the full 48. I'm using the height, the change in height to do it. I think that's the easiest way to do it. Another way to do it, we could actually work with the volume. Total volume to full it. And you divide that by the total volume that each fill will be. You can go and work out that one by yourself. I'm doing it the easy way, which is this way, is the easy way. Using the height. Because the height is moving by 13.2. Each time you pour a container in it, the height moves by 13.2. This is the height required to full it fully, because we're carrying it up to 48 and it is already at 28.2. So this is the height left to full it completely. If this is the height left to full it completely, and each time you pour in one of the container, it is moving by this amount, then to know the number of times or the number of containers you're going to put in there, you divide this total that is needed by this amount that it is moving each time. We get a perfect 1.5. So it means that you need one full cylindrical container and a half to full it fully. So that's it. 1.5 more containers you need to full the tank fully. 1.5. That is it. All right, that is it. So I think that's the easiest way to do this question. There's only 2 marks per attendance, so there's not no calculation needed. 2 marks. But that done. Next question. Pattern question. Pattern question. I don't think I need the calculation now. Pattern question. All right, so this question says, diagram below shows a sequence of figures made up of circles with dots. Each figure has 1 dot in the center. See it here? 1 dot in the center. And 4 dots on the circumference of each circle. So see, you have 4 dots around here, you have 4 dots around here, and 4 dots around here. Each circle has 4 dots around it, right? It said the radius of the first circle is 1 unit. The radius of each new circle is 1 unit greater than the radius of the previous circle. It said, except for the first figure, a portion of each of the other figures is shaded. So the shade in the outer, the shading here between the outer, 2 outer circles, basically. Sometimes all of that information is irrelevant, you know, if you can pick up the pattern formula. Once you pick up the pattern formula, this is not important again. It says, complete the rows in the table for figure 5 and figure N. Figure 5 and figure N. Now, as you know, well, figure 5 is the one that is going to come immediately after, so you can look at the pattern and see what is happening. But I like to fill out this first, as always. All right? All right, so what's happening here? This one is increasing by 4. Can you see it? That, don't it? See that? So because it is increasing by 4, the formula is going to have 4n in it. But because the first figure there is 1, is 5, is 1 more than 4, you have to add 1 to it. 4n plus 1. That's the formula. And then this one now is what? These are actually perfect squares of these numbers. Perfect squares. Can see that. So this one is 1 squared times pi. This is 2 squared times pi. This is 3 squared times pi. So this becomes n squared times pi. N squared times pi. This one now. These are increasing by 2 pi. See it? Increasing by 2. The first one is 1 pi. So if it's increasing by 2, you know, so it's going to have 2n in it. But the first figure just has 1 pi alone. So we subtract 1. And then multiply that by pi. Because it's always this number times pi. The value is increasing by 2. All right, over here now, a different pattern this. So this one increased by 4. And then it increased by 6. And then it increased by 8. So it keep increasing by 2 more than it did before. Through my experience, this is a n times n plus 1 pattern. It is n times n plus 1, because it is 1 times 2, then 2 times 3, then 3 times 4, you can see it enough. Then 4 times 5, give me that 20 here. So next one is going to be 5 times 6. So you see it's like n times n plus 1 pattern times the pi. So this pattern is n times n plus 1 times pi. Product of the number and the number after it. That's what these are. All right, that is it. That's the formula. Once we have a formula, we can fill this out now. Because all I have to do is drop the 5 on this. So it's going to be 21. I can add 4 to that. 21. You notice this one work out already because it is 5 squared times pi. Then this one now I need to drop. This one going up by 2. So it's going to be 9 pi. Or I can drop the thing on this one. I get 2 5 is 10. 10 minus 1 is 9. So you get 9 pi anyway. Then this one now is going to be, drop the 5 on this. You get 5 times 6. That's 30. 30. And you realize that this increased by 2, by 4. Then this increased by 6. Then this increased by 8. Then this about increased now by 10. Could I say that as well? So it's going to be 30 pi. All right, it's going to be 30 pi. So you could just look at it and observe that as well, the pattern. This is 30 pi. But this formula might give you a little bit of problem, but that is what it is. That's another one you need to look at and learn. More things you know, the better. If you use these as experience for yourselves. N times n plus 1. That's for the increase. All right. It's like you're adding 2 more than you did before. Add 2, then you add 4, then you add 6, and so on. Right? This is it. N times n plus 1. Next part says, determine the value of n when the number of dots is 541. So which formula is that for the number of dots? 541. So I have to find the formula for the number of dots. Number of dots multiplied 541. Number of dots. Oh, sorry. So this color 120. This formula equals 541. So this will be 541. That's why for 4n plus 1 equals 541. It's 4n. Yeah, 4n plus 1 equals 541. 4n plus 1 is 541. So 4n is 540. So n is 540 over 4. What that work out to? 540 over 4 is how much? How much? 134? 135. That's it. Done. Next thing. Write down in terms of P and pi the area of the largest circle for figure 3P. So this is where n equals 3P now. This means n equals 3P. N equals 3P. And I want the area of the largest circle. Let's see which column that is now. Area of the largest circle. See there. Area. Let's see, it's an area of the outer. Area of the largest circle, yeah, the outer circle. Area of the largest circle. So we're talking about the largest circle formula. So the largest circle formula is this one. N squared pi. So this answer becomes equal to the n is 3p. So it becomes 3p squared pi, which is 9p squared. 9p squared pi. I'll leave this as well, you know. But this is the answer as well. N is 3p. So it's 3p squared pi. But the n is 3p. Remember the formula was n squared pi for that column. N squared pi for that column. So we're applying that formula here. Formula is n squared pi. Question done. All right, section 2 now. Let's go. Section 2. The best section. It says a straight line is this. It intersects the x-axis at P. Remember now that on the x-axis, let's write it down. The y value is 0. and the y-axis at Q, and the y-axis, the x value is 0. All right, make it work out itself. It says determine the coordinates of P and Q. So P now, let's write down P first. P is a point where the y value is 0. P is a point where the y value is 0. So you're taking 0 and putting it here. So you see that x value is going to be 5. X value is 5. Easy like that. And Q now. Q is a point where the x value is 0. So you put in 0 here for the x value, working out the y. So you put in 0 right here for the x value over here. So we have to work it out. So for this one, x value is 0. So you say this equals 0. So you're going to have 0 equals 5 minus 3y. But the 0 is the x value. So then now 3y are going to equal 5. If I carry this negative 3 over here, it will become positive 3y. So 3y will be 5. And then divide by the 3. So the y is going to be 5 over 3. So I put in 5 over 3 right here. That is it. Nice and easy. That's the value of, that's the coordinates of P and Q. This one is on the x-axis. This one is on the y-axis. All right. Next part. Oh, them give us them here. Where's the same thing? That's it. If you leave them here on paper, I'm going to get marks. If I leave them right here, I'm going to have to force them in here to get my marks. They're there on the paper. They have to give them my marks. So it's 5, 0 if you want to put them in. 5, 0, and 0, 5 over 3. 5 over 3. Next question. Calculate the length of PQ giving the answer to 2 decimal places. This one kind of easy, you know. It becomes the square root of this value squared plus this value squared. Why is that? Because remember, it's like you have P down here, so, and this is 5. You have Q up here, so. So what means that this is the line PQ. But then this length is 5 because this point is 5, 0. And this length is 5 over 3. This length is 5 over 3. So if you want to find that length, you're going to use Pythagoras' theorem. So this length becomes the square root of this side squared plus this side squared. 5 squared plus 5 over 3 squared. Let's write it out then here. So it becomes equal to the square root of 5 squared plus 5 over 3 squared. If you want to use a formula, difference in y squared, difference in x squared, you're going to get the same thing. They want it to 2 decimal places. So let's get a calculator and work it out. So the calculator and work it out quick. So it's the square root of 5 squared plus a fraction. Let's put the bracket in. Let's put the bracket. Let's go back and put the bracket. Bracket. Fraction in there. 5 over 3. I'll put 25 over 9 if I want to. 5 over 3 squared. Squared. What decimal place is it? 2 decimal place. 5.27. 5.27 units. That's how long it is. Put the word units, because units is used to measure in coordinate geometry. So put the word units there. 5.27. Next question. Online, you there still? Everybody good?
Yes, sir.
Yes, sir.
All right, good. Internet kind of steady today. Because my data I'm using still. Hotspot. Next part says, R is the midpoint of PQ, the point determine the coordinates of R. Remember, R is the average point, right? So you're basically averaging these 2 values and averaging these 2 values. So it becomes easy. So this can become 5 over 2 and this over 2. So it's kind of easy, this one. So R becomes 5 over 2, which is the average of the x values, and 5 over 3 also over 2, same as 5 over 6. 5 over 6. But understand that? But good at that? Because the average of these 2 values, these are the x values, and you average them, it's going to get 5 over 2. And if you average these 2 values, 0 and 5 over 3 is half of that sum. So half of 5 over 3 is just 5 over 6. That's it. 5 over 6. Average of the x values, average of the y values. Next question, or that done. Next question says, function is given as this and that. Second function question that, you know. That one is a line, that one is a curve. We're to write them over. It's basically that f of x is 5 minus x, and g of x is this one, a quadratic, x squared minus 2x minus 1. It says the graph of f of x and g of x meet at these 2 points. Remember, these are like your y values, you know? So where they meet, these two things become equal. All right? It said determine the coordinates of m and n. So basically, we're going to equate that the meet where g of x equals f of x. That's where they meet. So the meet where this equals that. So the meet where x squared minus 2x minus 1 becomes equal to 5 minus x. That's a quadratic, but in a basic form. We have to transpose these and put it equals 0 to solve it the normal way. Put it in the standard form first. So transpose this x becomes a plus. So we're going to get x squared and minus 2x plus x becomes minus x. Transpose this, we get negative 6, because it becomes a negative 5. So we get minus 6 equals 0. And this factorizes easily, because the only factors of x squared is x and x. The one factors of 6, that the difference is this 1. That's 3 and 2. 2 and 3. Signs are different. Give the greater product the minus sign. That's a greater product. Give it the minus sign. Make this positive, all of that equals 0. So therefore, this factor gives me x equals negative 2. This factor gives me x equals 3. I need to know the y values now. So I can put them in this line equation to get the y value. So the y value to go with this is when I put the negative 2 in here, I get 5 minus a negative 2. I get y equals 7. So it means that one of the points is negative 2, 7. I can call that m or n, it doesn't matter. Then this one now, I'm going to plug it the 3 again in this equation. Plug it in the easier one. And the y value there is going to be 5 minus 3, which is 2. So the second point is 3, 2. So since I say m and n, I'm going to put this one as the m with the lower x value as if it comes first, and this one as the n. And that is it. So this guy is solving the equation simultaneously, a line and a curve. Very easy, soft, the capital T. Let's continue. Next question. If you get it wrong, go and do it over. Oh, velocity time graph, speed time graph. Remember, gradient is acceleration. Area under the graph is distance traveled. Average speed is total distance over total time. And the total distance is the total area under the graph. That's all you need to know about a speed time graph, and you're good to go. This question says, Monty is cycling at 12 meters per second. That's him here now. Going at 12 meters per second up here. So 12 there. So he's going at 12 meters per second. It says after 4.5 seconds, see there? 4.5 seconds. After cycling for 4.5 seconds. So the start of time when he is already cycling at 4.5 seconds. You know what? I check it from when him start cycling. So I can cycle and him start timing right here. He's already going at 4.5 seconds. And then after timing him, he's already going at 12 meters per second. After timing him for 4.5 seconds, he started to cut his speed. He started to slow down. Right? So after 4.5 seconds, he starts to decelerate, starts to slow down. Right? And then after 2.5 seconds, he stopped. So see there, after this 2.5 seconds right there, so he stopped. See there, this is 1, 2.5 seconds. He stopped. So it took 2.5 seconds to stop. All right? So here's when them stop. Stop after 7 seconds total. It says calculate the constant deceleration. Remember, deceleration is fall. Or deceleration. First is the fall gradient, right? Deceleration is the fall gradient. on a speed time graph is a fall gradient, which is fall over run, the fall over the run. And the fall is by 12. And the run is 2.5. This is when he decelerated. We're talking about the grade of this section right here. When he decelerated, right here, this section. The fall is 12, over the run is 2.5. What I work out to? You have to put meters per second squared. Meters per second squared. Meters per second squared. What I work out to? $12 over 5 over 2. That's 24 over 5. That's 48 over 10. 4.8. That's what I get. Check it for me. 4.8. Huh? One of them I work it out for myself. 4.8 meters per second. Then said monthly is average speed for the 7 seconds. Its average speed is total distance over the total time. And the total distance is the area. So see it here. This equals total distance over the total time of 7 seconds. The total distance is the area under the graph. That's total area. Because distance on a speed time graph is area. I'm writing out everything for you. I don't necessarily going to put this on an exam paper. I'm doing it for you because it's a topic that we did recently. That's why I'm doing this. Total area over the total time of 7 seconds. Now, what is the total area? It's the area under here, so we're talking about. It's a trapezium. Because they have two parallel sides, this side and this side. Let's put them on. This side up here is 4.5, 4.5. This side down here is 7. The distance between the parallel sides is 12. 12 is the distance between the parallel sides. Those are the numbers that we use in the area of this trapezium. Find that area. That becomes the area. All right? So let's work it out down here. So now, but don't give you a lot of space. Let's work it out. All right. So let's work on the area on the side. So the area is the area of a trapezium. Somebody listening something. Turn it off now. Turn off the music. Somebody wants some music. Jackson, is you have music? Jackson, that's the music in that class. Now I learn nothing. Half the sum of the parallel side, which is 4.5 plus 7, and the distance between the parallel sides is 12. See there? Half the sum of these two sides multiplied by the perpendicular distance between the parallel sides is 12. That gives us the total distance traveled. All right? That is the area. Is the distance traveled. This area up here. Write this out for me. Let me work it out myself with the calculator. Let's work it out over here. So this half of this 12 is just 6. I'm just going to write 6 times bracket 4.5 plus 7 close bracket 69. So this is 69 meters is the total distance traveled. So I'm going to come back to this now and put it over here. This becomes 69 meters over a time of 7 seconds. Work that out and you get the answer. 69 divided by 7. That's 9.86. I can leave as an answer, you know, 69 over 7. But you can put a 9.86. 9.86 meters per second is the average speed for the whole journey. All right, so spend a little bit more time on this one just because this topic that we did lately. Recently did this topic. That finishes number 8. Number 9 now. Let's go. Let's go. Question says, in the diagram below, A, B, C, and D, all questions set like this in recent times, A, B, C, and D are points on a circumference of a circle with center O. AOC and BOD are diameters. That's a diameter. It subtends 90 degrees here, so you must know that. Diameter subtends 90 degrees. That's a diameter. Subtends 90 degrees up here as well. All right, diameter subtends 90 degrees at a circumference. It says AB and BC are parallel. Once it's a parallel lines again, Z angles are equal. So for example, these two lines parallel. These two lines parallel. So this line now is a transversal line. It crosses both of them. So this angle and this angle equal. They are Z angles. So them two angles are equal. Also, we can look for the U angles. So those two lines again parallel. These two blue lines parallel. And they are joined down here by this line. So this angle over here, so, and this angle over here, so equal. Because they are, each of them are 90. Right? We said that earlier. All right, so you have to look out for those things, the U angles and the Z angles. All right, we also have this Z here, so Z here, so as well. So this angle and this angle is so equal. If you should come to that, that's a Z. Alternate angles. All right, let's answer the questions. It says, state the reason why angle ABC is 90. Where is that? Right here. Why? Because it is subtended by a diameter. Angle subtended by a diameter is 90 degrees. Right? Angle subtended by a diameter is 90 degrees. Angle subtended by a diameter is 90 degrees. That's why it is 90 degrees. Subtended by a diameter. Diameter is AC. If you want to say diameter is AC, fine. That's it. Next question. Determine the value of each of the following angles. Show detailed working where necessary and give a reason to support the answer. Angle BAC. Let's go up here now. Angle BAC, the one first. Angle BAC. BAC. That's this angle I want to know. And after that's 2P. Kind of funny. Did they ask for the value? Those values? They ask them for them here now. But this one angle first. BAC. This question kind of weird because to find BAC here, I need the value for P. I need to know what P is. So it's kind of weird, this question, how they set it, because this angle equals this angle, because they are both subtended by this. Right? Angle subtended by the same chord, the same segment are equal. Looks like I need to work out the values first in order to tell them this. I don't understand this question kind of weird. They ask me for the angle, they don't ask me for P. Looks to me like I need to know the value of P in order to tell them what it is. All right? So let's do some work on this. This angle is 90 degrees. They don't give me enough information. Let's see if we give you any other information later on. Hold on. Let's see. They're asking for Q. They're asking for R. All right. So we have to work it out. We have to work them out. All right. So I know that that angle is 90 degrees. The R plus that is 90 degrees. Not seeing anything else. I know that this and this equal. All right. Let's see if we can see. So we know that 2P equals Q. I want to say this is 90. It's subtended by the diameter. We know say 3P plus R is also equals to 90. All right. But the 2P equals Q. All right. We know something else. We know something else. This angle is 90 degrees. So them two angles here is 90 degrees. All right. I think that is it. That's what it is. But the total angle in this triangle is 180. This is 90. So them two here is 90. So we can say 5P equals 90 degrees. So P equals what? 90 divided by 5 is how much? 18. It's 18 degrees. Huh? That's it. All right. So question kind of weird. So 2p then is 2 times 18. So that? All right, so I'm going to use this as a premise for this. Let's do this calculation. All right, let's go. Question kind of set up different. All right. So for this angle, we're going to say, tell them that the 2p plus 3p equals 90 degrees. And so the 5p equals 90 degrees, or 90. The values are in degrees already. And so the p equals 18. And so angle ABC, angle BAC is 2p degrees, which is 36. 2 times 18 is 36. What's the reason? What's the total angle in this triangle? We already said that this angle is 90 up here, sorry, right? This angle up here, so I already say it's 90. What is the total angle in triangle ABC is 180 degrees. That's what we're going to say here. Total angle in the triangle is 180 degrees. That's the reason. Total angle in triangle ABC equals 180 degrees. That's the reason that we're going to put. That's what we use, basically. All right. But I already said up here that this angle up here was 90 degrees. We said that in the first part. And they will say, no, total angle in that triangle is 180. So if this is already 90, then them two here must add up to 90. All right. That's the premise of what you're saying it here. That these two angles must add up to 90. All right, that is that. So the angle here is 36. Let's put on the diagram. So this angle here is 36. This is 36. All right, that's 36. Then they want us to tell them angle Q. Where is a Q? This one. So these two angles equal, right? So the Q equals 2p because same segment rule. So this Q equals the 2p angle, which is 36 degrees. And the reason is angles in the same segment are equal. Angles in the same segment are equal. Angles in the same segment are equal. So the Q equal the Q2p angle up here. As you can see, right? Those two angles, this one and this one, equal. But they are both subtended by this chord over here. Up there and up here. All right, same segment rule. All right, what else they want? They want R. They want R next, right? Angle R. So R now is such that this angle here is 90 degrees. Right, it's subtended by this diameter. So the R plus 3p equals 90, where the p is 18. All right, so we can say down here, we can say that R plus 3p equals 90 degrees. So the R equals 90 degrees minus 3p. The p is 18, so the R equals 90 degrees minus 3 times 18 degrees. What does it work out to? Somebody tell me this one. Huh? What do I work out to? Huh? 36? 36 degrees. Let me see if the 36 for another reason. All right. Let me see what on. 36. Oh, yeah. Z angles. Because I've said Z angles. See? It equals this angle here as well. Yeah, Z angles are equal. So we got it another way, but that's all right. It equals 36 by Z angles. See the Z? Parallel lines, transversal line. These two angles equal. So, really like the question here. That's why I got sometimes. All right, so that's 36. I don't feel like this question really tests the knowledge of circuit theory. This one. I really test the knowledge of circuit theory. But anyway, let's continue. This question says, from a harbor H, the bearing of two buoys, S and Q, are 185 and 315 degrees respectively. So they show the 135, but they don't show the 315. They show this one, but they don't show this. Let's put on the diagram the 311, sorry. So there's the bearing of S and Q, the bearing of S and Q from H. So it's from H. So H is the from position right here. And so we're trying to get the bearing out to Q. So see here now, this angle they're talking about, all this angle around here is 315, you know, all of this. 311, see, 315. That angle. So it's from the from position out to Q, north line clockwise, that angle is 311. Let's mark it. All of this angle is 311 degrees. So that is 311. And this portion, if it is 185, then inside is the difference, right? 311 minus 185. What I work out in between there. 311 minus 185, 126. So inside is 126. Let's put on the diagram. Inside is 126 degrees right here. 126 degrees is the angle inside here. And we can fill out this angle here too, because it completes the 360. Let's put on in blue. This angle over here, right here, is 360 minus the 311, which is 49. So this angle is 49 degrees right there. All right, so we're kind of filling out some of the information there. Because total angle around the point is 360, and this is 311. So subtract from 360 to 49. What does it says? It says the Q is 5.4 from H. So from Q to H is 5.4. Let's put on the diagram here. 5.4 kilometers. That's this side. It's 5.4. Let's put it on. Let's put it on in purpose so it stands out. This is 5.4 kilometers. That's this side. And then S from H is 3.5. That's down here. 3.5. So this side is 3.5 kilometers. So let me put this angle inside there in purple, 126, because it becomes relevant. 126 degrees. So we have a situation now of two sides, and an angle between them. So we're going to be able to use cosine rule to find the length of this side over here. All right? All right. This is in degrees. All right, so let's answer the questions now. All right, so as I read, I populate the diagram. Question says, on the diagram below, it shows a sketch of the information. Insert the values marked. Insert the value mark angle QHS. QHS. That's right here now. Put it in already. The angle 126. See? Insert the value for angle QHS. QHS. That's this angle. Put it in there already. 126. Didn't even know they asked for it, but that's it. That does make sense to populate the diagram. That's 126 they're asking us for. So this is asking for the angle of 126, which we put on the diagram. All right, next question says, calculate QS, the distance between the two buoys. So that this distance asking us for now. Cosine rule we have to use. So let's do it. Let's do it here and then copy it down. All right, so cosine rule. So start like Pythagoras theorem. Remember, treat this like this is the hypotenuse to start, like this is a 90 to start, and you have to subtract the piece. So it's gonna be QS squared equals 5.4 squared and the 3.5 squared. Let's put the smaller one first. 3.5 squared plus 5.4 squared. Start out like Pythagoras theorem, but you have to subtract the piece. So you subtract 2 times the 3.5 times the 5.4 time the cos of the angle between them 126 degrees. This is actually going to add a piece because it's longer than an hypotenuse, because the angle larger than 90. But what means that the cos of the 126 is negative. The negative makes this positive, and also you actually add a piece in this case. You get me? So instead of putting the square on this though, I'm going to take out the square and put the square root over everything here so we have less work. You have to practice to do it that way to save time. All right, so let me copy this down now, or cut and paste it down where we need it. Let's put everything in the calculator at one time. Notice I don't give a lot of space, but do a lot of steps in this work. You have to practice to be efficient with these calculations. So now it's a matter of typing this in the calculator and put the answer right here one time. You don't need to be doing, you don't need to be calculating each part. You don't need to be calculating this part and that part and all of that. Waste of time. Let's put everything in the calculator right now. All right, with the square root. So we're going to start with the square root, the 3.5 squared. Then we add the 5.4 squared. Then subtract the 2 times 3.5 times 5.4 times the cosine. Make sure the calculator is in degrees. Yes, it is in degrees. 126. And that is 7.7. I'm going to give, well, they've been giving us 2 decimal places. But I'm still going to work with the standard of 3 significant figures. So I'm going to write 7.98. And this is what? Meters or kilometers? Kilometers. Kilometers. Put this on the diagram as you find it. 7.98. I'm going to put my 7.98 kilometers right here. Put an equal in front of it to say that it's something that we worked out. Now that I have this angle and side opposite each other, I can use sine rule going forward. The only thing I don't know in this triangle now are these 2 angles. So if I need to find any one of them, I can now use sine rule because I know the angle and side opposite each other. I know both of them. I know the angle and the side. All right, so that is that. Next part asking us for a bearing. Let's focus on it now. They want the bearing of S from Q. When you're doing bearings, you have to make sure you take note of the from position. The bearing is measured at the from position. It's from Q to S. So when I do the bearing at the from position, so you need the north line at the from position. Always note the from position. So it's from Q to S. So let's put the angle on the diagram and do it from Q down to S. So it's from this point down to this point. I want the bearing now. All right, so let's draw it out. So this is the from position. You need the north line there. You need the north line here. Let's draw it in blue. The north line. So we need this north line. And generally speaking, if you want the angle from this point, 90% of the time, the angle inside the triangle here will play a part in the calculation. That angle will play a part in the calculation. So now I'm going to just mark it. This is my north line. Let me extend it up to the right. That's my north line. I need the north line at the front position. And the bearing angle that I want, let's put it in red. Is the angle from this north line clockwise to the line taking me out to S. So that is this angle now that I'm going to put a red theta on. That's the angle that I want. Right there. All right. Now, how can I get that angle? I know that I'm going to need the alpha. And so if I'm going to need the alpha, then I also need to know this piece right here. From here to here. So the theta will be equal to this angle plus alpha. So what is this angle in here? That angle kind of easy, you know. Because remember, this angle now, this angle that I want is co-interior with this 49. Because there are no angles inside this U that I'm drawing on the screen now. It's U. Angle inside is U. So this angle here and the angle that we want inside here, they are supplementary. We call them U angles. They add up to 180. All right. So it means then that this angle in here that we want is 180 minus this 49. 180 degrees minus 49 degrees. What that work out to? Minus 40 first, we get 140 minus 9 more, we get 131. So that's 131 degrees. And I'm leaving this on my diagram, this calculation. So the bearing angle theta becomes 131 plus alpha. And we're going to have to calculate the alpha using sine rule. All right? We're going to have to calculate the alpha using sine rule. This alpha in the diagram here. We're going to use sine rule and calculate it. Let's show the working on the screen. We're going to get the alpha. So we're going to use sine rule for alpha, right? I'm going to copy it down. We're done. Sine rule for alpha. Start with the sine rule. Hey, touch our young lady for me. Touch her for me. Both sides. Both sides. Both sides. Come class for sleep. Just sleep both sides. Sine of alpha over the side opposite alpha is 3.5. Equals sine of the angle that you know, which is 126. Over side opposite to it, which is that side, which is 7.98. Sine rule to find the alpha. And then to find the alpha, notice, you know, guys, all of the bearings can stand them are the same thing all the time, and there's different angles, different values. All of the questions are the same thing. You just need to go and do one of them or do a couple of them. And you find that you're repeating the same activity, the same action you're doing on all these questions. With different angles, different distances, but the same thing all the time. To find the alpha, we're going to multiply the 3.5 first, put it in front, and then take the inverse sign. So the alpha is going to be sine to the minus 1 of the 3.5 times the sine of the 126 degrees divided by the 7.98. Put this in the calculator and get the alpha that you need for the bearing. See here, the bearing up here that we want is actually equal to the 131 plus this alpha inside here. I'm calculating the alpha down here. I'm doing it on the screen so that we can see it. I copy it down where it's supposed to be afterwards. And this alpha works out to be what? Now put it in the calculator and we'll get the alpha. Let's put it in the calculator to get the alpha that we're going to use back right up here. So we need sine to the minus 1 of a fraction. The fraction is 3.5 times the sine of 126. And you put that over the 7.98. The angle is 20.8. 20.8 degrees. So you put that right here. So the angle that you want up here then is now 131. I'm doing it on the screen right here. So it is right in front of us. Becomes 131 degrees plus 20.8 degrees. And you wrote that out. I'm just going to add the 131 to this. So I get 151.8 because it's bearings, you put it to 3 digits. And that's right, 152 degrees because it's bearings. You always give bearings to the nearest whole number, 3 digits. That is it. So I just need to copy this down. Let me go and put it down here. So on the exam paper, I would say something like this. I would say something like this now. The bearing of S from R equals theta. And I will say the theta equals 131 degrees plus alpha. I'm going to show how I get the alpha now. I'm going to say, all right, sine rule for the alpha. And then I will do the sine rule calculation that I just did right here. This one. This one. I'll do this sine rule calculation. Copy it down. I'll do the sine rule calculation right under here so now on the paper. Right here. Let's change it to red. Move this and put it underneath here. The sine wave calculation that we just did, that's what I'm doing here now. That's what I would do right here. And then alpha would be the, we get again 20.8, 20.8 degrees. Now use 20.8 degrees right back up here now and get the theta now, the bearing angle, which is theta then is 131 degrees plus 20.8 degrees. And so I will get the 151.8 degrees. Because it's bearings, I'm going to round it up to the nearest whole number. I round it off to the nearest whole number, 3 digits, 152 degrees, and that's my answer. It don't make no sense. You watch, sir, the 50 of them question here, I can't do what. That don't make no sense. And the 50 of them are the same thing, with different numbers and angles. It don't make no sense. Okay, don't take the time to go and sit down and just take your time and go through one for yourself. And follow the same process. And do the same one 5 times if you have to. And then you see how easy they are. And then they are asleep. Can't sleep and learn nothing. Never seen nobody asleep and learn nothing yet. Think sorry for yourself, you're not going to pass the exam. Sorry for yourself, you can't make you pass the exam. You put in the work if you want to get the results. Put in the work and you get the results. Do what I'm telling you for do. Exam easy to pass, you know. CSEC maths easy, you know. Easy. And it gets easier and easier and easier as time passes. And we have far more things available to know than what was available in the past. So in the past, it will be much harder and less resources available. Now it's much easier and far more available resources. So excuse me now. I don't have the same brain like what people used to have before. Come on, man, I don't pity phone, you know. Put in the work if you don't want the results. Put in the work. Come with sad faces and asleep. Sorry for saying you can't make a pass exam. Put in the work and you will get the results. Last question. So I'm killing the work. Tomorrow, one more paper on a skin. And Wednesday, one more paper, and Thursday, one next paper too. And put in the work. No one results, put in the work. And Saturday, 2 more paper again Saturday. Do them. Next question. They give us this matrix W. So a 2 by 2 matrix L is such that W plus L equals 0, 0, 0. This is the identity matrix for addition. It's the identity matrix for addition. The identity matrix for multiplication is this one. 1, 0, 0, 1. When you add 2 matrices and it equals 0, the 2 matrices are inverse of each other. Easy. All it means that all of these values, when you negate all of those values with the L, you get the 0, 0, 0. So you can literally write down the answer. L has to be the negative of each of these values. So you add them to get the 0, 0, 0. So if this is W, then the L has to be that the values on this are all negative. It's not a calculation, you know. The negative of 3, negative 3. The negative of 6, negative 6. The negative of negative 2 is 2. Negative of 5 is negative 5. When you add this and this, you get 0, 0, 0. It's not a calculation. It's a simple thing. All right? But go to that. So it's 1 mark for it. That's so easy. But okay with that? Good. Next one says, the 2 by 2 matrix P is such that WP equals that. Now you must know that a matrix times its inverse equal the identity matrix. It means that P is the inverse of W. Because W times W to the minus 1 equals this I matrix. This matrix is called the identity matrix for multiplication. This 1, 0, 0, 1. So this P has to be the inverse of W. This P has to be the inverse of W. So you can write that P equals W to the minus 1. So you work out the inverse of W, you are finding P. See that? That's what this is. This is testing your knowledge of this information. That the product of a matrix and its inverse gives you the identity matrix. This matrix right here is, sometimes they put I on it instead of the 1001. I put I instead. Must know that. So to calculate the P, we just need to calculate the inverse of W. This is a W right here. Right? We'll put it right here. The W, remember now, is 36 negative 25. So to get P, we just need to calculate the inverse of W. Let's work it out right here. So it becomes 1 over the determinant of W. The determinant is this product, the first diagonal product, which is 15, minus this product, which is a negative 12. So you're subtracting a negative 12. So you put minus negative 12. Minus minus is a plus. So they actually add to 27. This minus is a plus. So this works out to be 27. Putting it there. They multiply that now by the adjoint matrix. So it's 1 over the determinant times the adjoint matrix. To get the adjoint matrix, to interchange the elements on that first diagonal. And some people call it the leading diagonal or the main diagonal, the first diagonal. 5 goes here, 3 goes here. Leave these 2 elements on the second diagonal where they are and change the sign. So this value becomes a negative 6, same place where it is. This negative 2 becomes a positive 2, same place where it is. And then when you divide each of these values by the 27, you have found the inverse matrix. So it becomes 5 over 27, negative 6 over 27, 2 over 27, and 3 over 27 is really 1 over 9. This can simplify to you, but no problem. 3 over 27. If you want to simplify them, the ones that can be simplified, 5 over 27. This is the same as well. 23 can go into this goes 9 times, right? So this can become 2, negative 2 over 9. Then this is still 2 over 27. And then 3 into this goes 1 time. So this is 1 over 9. 1 over 9. So you could put that as the answer as well. So you have to know that a matrix and its inverse gives you the identity matrix. If it's two matrices multiplied, and the answer is the identity matrix, it means that they are inverses of each other. So the one that you don't know is the inverse of the one that you know. Simple. So to get P, must calculate the inverse of W. That's it. Next question. A different matrices question is actually transformation, it looks like. It says a right angle triangle M has vertices x11, y31, and z34. It says when S is transformed by this matrix, I must know that matrix. That matrix is a reflection in the line y equals x. That matrix reverses the x and y coordinates. The more things you know, the better. If you don't know, you can do like a quick test with it. See here, 0, 1, 1, 0. If you multiply that by a matrix xy, it's going to become yx. You work it out because this 1 times this give you that. And this 1 times this give you that. So it maps a point xy onto a point yx. So the more things you know, the better. I don't have to calculate nothing. But that's it. Y equals x reflection matrix. It interchange x and the y values. Don't have to calculate nothing. Reverse these coordinates and you get the image point. See? Find the coordinates of the vertices of the prime triangle. That's the image of these points. So I'm just going to write it. X prime. Reverse 1, 1, it stays 1, 1. Y prime. Reverse 3, 1, it becomes 1, 3. Z prime. Right, the prime are better. Sure. Right, this prime are a little bit better. Right, Z prime. Reverse 3, 4, it becomes 4, 3. And this is my explanation for why I get that, why I did that over here. I just did it. This is showing the examiner why I reversed those values. So I'm leaving this on my paper. So this matrix, reverse versus X and Y coordinate. Because reflection line Y equals X. I tell you guys to learn the matrices. See examples you have why you must know them. I tell you now everything you need to know to make exam easy, you know. You have to decide on what I'm going to do it or not. I tell you now. These are the matrices that will come in the exam. Get the marks, get the 2 marks, quick and go about the business. Make other people struggle upon them questions. Them too easy. If anybody struggle upon them questions in the exam room, you know the answer before you do it. That's what I also told about transformation question. You can know the answer before you even do it. You don't need to work out nothing to know the answers. But there are certain basic things that you need to know first. Arm yourself with the knowledge of those things. Put in the work, you get the results. Next question. Vectors. Easy. The diagram below shows triangle OPQ, in which OP is 3U. Right up here, it's 3U, and I break it down for you. So they might help you, they break it down for you. 2 part, 1 part. Then OQ is V, right here, so right here says V. That vector is V. It says Q is the midpoint of OR. Q is the midpoint of this line. What that mean? It means that the vector from here to here is also V, right here, so. Because if them 2 lines are the same length and the same direction, same line, then it means that the vector right here is also V. I'm going to put it on. This vector is the same as this V right here, so V as well. Same vector V. So this out here so is 2V. OR is 2V. It says M is the midpoint of PQ. So this is the midpoint of this line. All right, good, no problem. M is the midpoint. So M is the average of this vector and this vector. You know. OM is the average of those 2 vectors. Right? But no worries. I can also know that PM is half of PQ. Right? So it all depends on the question. I'll know how to treat with M. Then it says L is a point on OP such that OL is 2/3 of OP. But they actually put on the values first already. So they break it up first already. So this common language is actually useless. Because they help us. They break up the 3U already into U and 2U for us. That's what that vector would do, that information would do. Right? That's why if you notice the whole thing is 3U. And the OL is 2/3 of 3U. That's why this is 2U right here. So they help you. By putting on these, they're helping you. First time they will just give you this and you have to figure out those 2 vectors. But no problem. As I said, the exam get easy. Question must calculate the vector LM. LM. All right. So look what is that mean now. So how do I go from L to M? So they don't ask for the PQ first, you know, but this question only need the PQ first. You can do it 2 ways. You can find OM first, but you can find the PQ as well. So let's work out the PQ over here. They didn't give me. I know that I need it. I'm going to work it out on the screen right here. So I'm going to work out PQ right here. So PQ is OQ minus OP. O times the last minus O times the first. Why am I doing it that way? Because I know the OQ and I know the OP. See them here? I know them both. So this basically just becomes 3U. No, it becomes V. OQ is a V. It becomes V minus 3U. Same as saying to go from P to Q, I can come minus 3U plus V. I can look at it this way. I can do a V out here, so, and then do a minus 3U this way. This is a V, you know, that's a minus 3U, you know, as I'm set up my parallelogram. All right, so that is correct. So this is my PQ. And then PM is just half of PQ. PM is half of PQ. Why am I doing that? Because I know that to go from L to V, L to M, I'm going to use PM. So PM then is just half of this. So it is half of V and minus 3/2 of U. That's what I get when I have this. All right, so back on the diagram now. To go from L to M, look at the diagram. To go from L to M, I'm going to come up to P first and then go from P to M. So I'm going to say it is equal to LP and then PM. Right? And the LP is just U. And the PM is this, which is half V minus 3/2 U. So I'm going to put this in a different color that we did on the side. Let's put in a different color. Let's generate. And let's make it a little bit smaller as well. That's my little rough work. And so I'm working this out now. So I'm going to consolidate the U values. This is a whole U. Well, this is only V there. So I'm going to write half V first. This is a whole U. This is minus 1.5. 1 minus 1.5 is negative a half. Right? This is a whole U minus 1.5 U. So that becomes minus a half U. Then I can check if this answer makes sense. I can check if this answer makes sense, you know. This is saying to go from L to M. I must go half in the direction of V and then minus half U. So see it here now. So go from here to here. I'm going to test it and see if it makes sense. It has to go 1/2 of V. It's a 1 whole V now. So this looks like 1/2 of V is about here. So let me transfer the length up here. So that's 1/2 of V. And then now this will come minus 1/2 U. So 1 whole U here now. Half U is about this. See there? So it makes sense. Look like it's right. Right? A whole 1/2 of V. That's 1/2 of V. And then this looks like minus half U. Because a whole U that came all the way down there. So this, a whole U. So the answer makes sense. I can accept the answer that I've gotten for this. It makes sense based on the diagram. And that's another thing with vectors. What you get by calculation, what the diagram shows you, must be consistent. So for example, if I got a plus right here, if I got a plus right there, I don't know that's something wrong. Because if I go half V, which is this way, and then plus half U be sending me that way, away from the M. So I know that it will be correct. You get me? So that's why sometimes your ability to double check from your diagram is good. The diagram and your calculation must be consistent. Next question says we have to calculate PR. Let's look at the diagram now. How to go from P to R? From P to R. This one is pretty easy. Why? Because I know the OP is 3U and I know the OR. The OR is 2V. Right? So because of that now, this becomes easy. Let me copy these down. Right? OR is 2V. So because I have those two things, I'm able to calculate PR. Let's do it in red. So the PR that I want is simply going to be OR minus OP. O times the last minus O times the first. The OR is 2V minus the OR is 3U. That's it. That is PR. Then the classic question down here. So show that L, M, and R are collinear. L, M, and R are collinear. To show that L, M, and R are collinear, you need to show that there are two vectors between the points L, M, and R that are parallel. And there's going to be a common point. How you show that vectors are parallel? You have to show that one of them is a multiple of the next. So first we need to do is decide which two vectors we're going to use between the points L, M, and R. And sometimes you'll have some already, right? So L, M, and R looking for. I'm looking for if you have any yet. L, M, and R. So we have LM already, so we can use LM. So now we're going to use LM. So I'm going to write it down. LM is this and put it here and just copy it down. LM is this. We're going to use LM. So we're going to use this vector. Copy it down. Right on the vectors we're going to use LM. And which other vector we're going to use? I've used a vector now with the R in it. There's either LR or MR. Right? So let's look. Which one is easier to find? Either MR or LR. See here, these are the points that are on a straight line, you know, L, M, and R. I'll show it to the vectors method. So which one is easier to find? MR or LR? Which one vector is easier to find? Look at the diagram. Which vector is easier to find? The LR vector or the MR vector? Which one is easier to find based on the diagram? Which one is easier to find? LR or MR? One of them. Which one is easier to find? Huh? I'm going to say MR easier to find. Why I say easier to find? Can I closer? You know, easier to find. LR easier to find. Can I just come down here, so minus 2u plus 2v. You have the values there. The LR is easier to find because you know the position vector of the two of them. You know the position vector of the L, you know the position vector of the R. To go from L to R, you just come down here, so which is minus 2u. You can see it. And go 2v over there, so. For the MR, you don't have the information. You don't have all the information for MR. Because you don't know that vector, you have to do calculations to go from here to here, so you have to calculate. To go from L to R, you don't have to calculate, you just have to look and see. Or you go from L to R. To go from M to R, you're going to have to calculate. So the LR is easier to find because you can see clearly how you go from L to R. Minus 2u plus 2v. Because out here, somebody put the v point out here already. We put the v out here already. So go from here to here, so see there, come down here, so minus 2u that. Why is it minus? Because we're going in the opposite direction. Plus 2v. Minus 2u plus 2v. Or you can say, I know OL. See there, I know OL. I know OR. So LR is defined because it's just OR minus OL. And I know the two, I don't have the position vector for M. So it's easier with LR. Come on, man. I explained this multiple times already on other questions. I still have to tell my foolishness. I don't know how to practice nothing. That's the problem. When I go today, I'm going to stand the whole day and learn something. I'm going to question for them. Exam is 5 weeks away. When I wake up. Question them easy. When I make them easy. And then I practice. LR is a perform. It is just minus 2u plus 2v. It's obvious on the diagram. Minus 2u. You see why it's minus 2u? You can see why it is minus 2u. To go from L to R, you can see it. To go from L to R, going along the vector directions that we know. You have to come down here, so come down. Okay, you're going in the opposite direction to the 2u. That's also minus 2u. You're coming down to O first. This way. And then this plus this are 2v. So to go out to R now is 2v. 2v. Minus 2u plus 2v. You know, if you make easy things, you know, if you make easy things so easy, look easier, you know. That's so easy already, but don't know if you make it easier. Serious. Teacher work hard, you know. Teacher work hard because teacher will try and make easy things look easy when it's already easy. LR is minus 2u plus 2v based on the diagram. But since I want to have the v in front, I'm going to switch these around, put them in the same way, same order. We want to show that vectors are parallel. So I'm going to write LR then equal 2v minus 2u. Then when we have two vectors now, I want to show that they are parallel. We need to show that one is a module of the next. We need to bring the two of them so that we can equate. What we always say, get rid of any fractions first, don't it? So the fraction here, so. But it's easy, you know, to get that side here to become that side here. But just need to multiply that one by 4. Can multiply them half by 4, they will become 2 like that. That's the whole idea, you know. You want the two vector them to become equal, of equal components, so they can equate these sides and show that one is a multiple of the next. If you don't practice it, you won't be able to do it. So I want the two of them to have the equal components, so we can equate the vector parts to show that one is a multiple of the next. I can clearly see that if I multiply that one by 4, it will become like that. So I'm going to multiply by 4. And now I waste time, I multiply by 2 and I multiply by 2 again. Multiply this one by 4. When I multiply that one by 4, this one multiply by 4, I get 4 LM. Multiply this by 4, I get the 2V. Multiply this by 4, I get the minus 2U. See the two of them equal now. So because them equal now, we can equate. We can equate the vectors. I don't remember all them things yet. This becomes equal to that. Because the two of them equal the same thing. So it means that the LR equal to 4LM. And that means that them collinear. But you have to write it out. This now means that the vectors are collinear. Why somebody have to do the same thing 100 times for you can do it one time? Huh? Why? Because you now do it 100 times too. That is the problem. I'm telling you, every time I do a question, almost go and do it. Do it over. So I'm always telling you, but you guys don't do that. That's a problem. If you get serious, exam around the corner, and exam 5 weeks away, getting closer now. When exam reach, we can't help on again. When exam reach, we can't help on again. When exam reach. I try showing this from last year. We do this early, from before December. And I tell me, say, MR easier than LR. I'm going to do other question marks on the same thing already. More than one time before. Come on, man, not joke. I get me upset now. Now that you have this equation, you have to go state the conditions for collinearity. What are the conditions for collinearity? You have to state the conditions for collinearity. And this has the conditions built in it. 1, because one vector is a multiple of the next, because one is a multiple of the next, it means that the vectors are parallel. Once you get an equation like that, a vector equation like that, we are able to show that one vector is a multiple of the next one. It means that they are parallel. That's what you have to do. That's what they need for points to be collinear. 2 things must happen. 1, first one, that they must have parallel vectors. And this means that they are parallel. So L, M is, instead of writing the word parallel, I'm supposed to put a symbol for parallel. 2 lines like that. LM is parallel to LR. I'll put LR first. LR is parallel to LM. That's the first condition for collinearity. The second thing that must happen for points to be collinear, that they must have a common point on the 2 vectors that are parallel. See there, the L is a common point on the 2 vectors. So you have a common point on the 2 vectors that are parallel. Say it. L is a common point. Once you have those 2 conditions, it means that the points involved are collinear. So we can write that as a conclusion. You have these 2 things. So you can state the conclusion and say, therefore, L, M, and R are collinear. Meaning that they are on a straight line. 3 points are on a straight line. And you're done. Only need to go home and do over the question them on the don't get. And about the foolishness. I mean that literally how me say it. I mean no other way. Go home and do them over pen to paper. I mean watch over the video and just watch it. I mean look for the solution. I mean put pen to paper. Get a blank sheet. Get the same question paper on another group. Work out the question them. When you're done, you look on the video and see if you have the same answer. Or you look on the solution and see if you have the same answer. If you don't have the same answer, look what you did wrong. Do it again for our next blank sheet of paper. You want to pass the exam and do well, that's what you have to do. And start the foolishness. I don't mean go watch, just sit down and watch a video. That no work. It have 100 million videos on YouTube where people can go watch. Or people still have fail exam. Because a lot of people just go try and watch. That no work. What works is doing it out of your head on a blank piece of paper, out of your own brain. Do it, swear correct a mistake by doing it over again. Not just say, okay, make a mistake, yes, and don't do nothing. When you see the mistake where you make, do it over and don't make the mistake while doing it over. Mathematics is a doing subject. It's not a watching somebody do it subject. It's not a reading subject. Because that was the case. People that just read books are all right. People that just watch video are all right. More than half of the people who do math still failing with all that is available. You know why? Because people still not doing what makes mathematics easy, which is to do the questions. Can't lazy and gain success in this thing. Can't lazy. Put in the work and you will get the results. From next week, more start saying, the grades have to start move from next week. You know? The grades have to start move from next week. 35% done with. We are going at 40% now. Them they're still failing grades, you know. I don't want to try to ask them to pass the exam yet. At this stage. I don't start trying to ask them to pass it. But you have to start improve. Things will not get wrong now. You're not supposed to get them wrong next week. When I the same thing the question I ask you. You can show the question what the same thing I'm right, you know. And the value is different, you know. I can show the questions where it's the same exact thing they're asking. It's just the values different. The angles different. The values different. The points different. One question is the ABC, one next question is the element, one next question is the PQR. Same thing they're asking. But that makes sense when I get in the wrong. When I'm asking the same thing over and over and over again. That makes sense. Same question I asked you a while ago. Which vector is easier to find? I asked you about 5 times already. When we do the topic, I want to still tell me the wrong one. That's why I get upset. I want to still tell me the wrong one. I'm going to explain why the other one before was easier and why I must use the easier one. I want to still tell me the wrong one today. After we do this thing, how many times already? You can't stuck at the same place. You can't stuck at the same level. You have to improve. You have to improve. And there is a way to improve. I'm telling you the way to improve. But the problem is you not do it. I don't want to come here no more, even come sit about the phone and watch the game and I play nothing, you know. When I come here late, if I come here late, you must have work out something. Sit down somewhere and work something. You know that I glad all the time. You don't have time for waste now. I have 5 weeks left. I don't know, quint 5 weeks done. I don't know, quint 5 weeks done. I know in an exam room, sit down. You don't want to have an easy time in the exam room, do what I tell you to do. Work hard now so that the exam easy. Work hard now so that the exam easy. Exam not for hard. Exam not for be stressful. You can go in an exam room and have a fun time in there. And that you must prepare for. That may I prepare for. You have to do what I tell you now. If you don't have a fun time in the exam room, just a breeze through questions. So. A breeze through questions. So. You have to do what I tell you to do. To the T, exactly what I tell you now. So Mr. Go and work over the question them, and that mean. I mean say go watch over the video, just watch it. I mean say pause the video, work out the question, then you check it. Put time in it. Put time and effort in it. I mean I talk to who up online too now. Them there, let me see them there. You know there? Hello?
Yes, sir. Yes, sir.
Oh. On about the foolish system, I talk to you, you know. But if it's out in a classroom, it goes to one two out there. Or listen. All on. So I'm started the improvement from next week and cut out the foolishness. When you hear that, make sure I see the improvement from next week. We have mock exam Wednesday, we have mock exam Thursday, one paper Wednesday, one paper Thursday. Those who come in the classroom, doing it in the classroom. Those who are at home, doing it at home. If you have a next class and you can't do it in the night. Get up in the night and do it. This 10-hour sleep business done with till exam done. And 12-hour sleep business. You young, you can live on 4-hour sleep or less. You don't need no 10-hour sleep and no 12-hour sleep. Come on, man. You don't waste no time on sleep so much. If you can't do the paper because you have other classes and so on, when you reach home, eat, you come to eat, no time for your YouTube and foolishness or watch a movie and no time for that. Them days are done till exam done. When you get up in the night, take a sleep, wake up in the night, allot 2.5 hours, 3 hours in the night, do it. And then go back to sleep. And wake up and go to school. If you're serious about this thing, these are the things you do. Make sacrifices and put in effort. If you're not serious about this thing. You get me? If you're not serious about this thing, you make a sacrifice. There are certain things you have to give up now. You don't have time for waste to watch video and play games and all so. Them things you don't put up them something now. If you're the perfect math, you don't have a problem. You don't have a problem if you don't want to play a game. If you know someone perfect in the math, you're not perfect. You still have things to learn, you still have things to improve on. So let Eleanor waste time or do other things. You don't have so much things you need to improve on. You have to which better perform not to be the wrong one. Don't get me upset, man. All right. Let me cuss the whole day now and get my vexed now. You have to improve now, maths now. You have to improve and maybe see improvement. Because we're not supposed to get grade 1. A grade 1 teacher not get enough. You think a grade 2 and grade 3 teacher not get. You not get grade 1 teaching. 1 is straight A's teacher not get. Grade 1 is straight A's teaching. You not get in a class here. If you don't come out to less than that, a joke not a joke. Oh, all right. So tomorrow. Make sure you come online tomorrow. I do next paper tomorrow. Anything you don't get wrong, do it over. It's a blank sheet of paper, work over the question, then you check the video. I'm going to post the video right now. Another group. Anything you don't get wrong, do it over. Do it over 5 times if you have to until you get it right. You can't commit the same mistake next week. You have to improve. All right. Bye, everybody.